off these technical and hands-on sessions. This is going to be a workshop about self-executing smart contracts. So no off-chain bots, no off-chain schedulers, just keeping it all on-chain with self-executing contracts. So for that, join me in welcoming to the stage Kieran Pakai.
All right, guys, the sessions are back on. I'm just going to switch the camera around, and hopefully this goes well. If you guys can't hear, just let me know, and I'll try to adjust the mics, do the best we can.
Hi, everyone.
Should be good, though. I'm sitting
This is
right under the
Michael,
mic, so.
Developer Advocates. Before I say anything, I want to demonstrate, and action speaks louder than words, or so I've been told, so I'm just going to demonstrate what we're going to be building today. So here I have a contract, a simple contract. Again, we can look at the code later, but for now, what I'll do is I'm going to pay special attention to this contract address, ends with 37E. What we're going to do, I'm going to go to calls and see all these different transactions. You see, we have these transactions occurring every 15 seconds or so. We're going to see one in a little bit here. But if we go to Events tab, we see, okay, every time, every transaction is printing hello Hedera every 15 seconds. And if we look at any one of the transaction, let's dive into it a little bit here, right? Okay, so here, well, let's just go to the events, that's fine. So, you might be wondering, well, why are these events being printed every 15 seconds? Trust me, I don't have a person somewhere executing these transactions. These are actually happening in real time. What's happening is every 15 seconds, the protocol itself is waking up our smart contract and calling a specific function and then printing the message, in this case, emitting an event. And you might be wondering, well, how is this happening? Like, we don't have any off-chain infrastructure, off-chain bot server, there's no Chainlink Keeper, Gelato, like none of this. It's all happening on-chain. It's the protocol doing it. And today we're going to be deploying the exact same contract. We're going to do it live, and hopefully all of you can also do it live with me, because it's quite easy to get started here. Let me go back to slides. All right. So the agenda for today, first I showed the cron job that was happening on chain. These transactions are happening every 15 seconds automatically, and we're going to talk about what exactly enables that on something like Hedera. Like, you don't see this on other EVM chains like Ethereum or Base or anything else. You need to use this off-chain infrastructure. And we're going to talk about Hedera scheduled service. And then after that, we have a hands-on exercise. We're going to be deploying the contract. And then we're going to talk about some use cases that this specific scheduled service enables. And then some of the next steps. All right, first of all, when we talk about any kind of smart contracts, they all have an automation problem, right? Smart contracts, like we've heard this term smart contracts since 2015, but can we really say they are smart in the traditional sense? Because if you think about it, a smart contract, all it does, it sits on chain, it doesn't do anything by itself. Someone manually has to poke at it by sending a transaction, and then it executes it, right? There's no like, if the transaction is not executed, if the transaction is not triggered, then it's not executed. It's as simple as that. And it's almost like when you have all these kind of things happening, like some of the times when you're dealing with time-based capabilities you want to introduce on your contracts, you have to rely on some off-chain infrastructure. We talked about Chainlink Keepers, and you may even have your own cron job running somewhere that is executing these transactions every so often, every day, every week, whatever. But when we're dealing with time-based capability, right, as an example, right, if you want to rebalance a vault in a DeFi setting every hour, if you want to have a recurring payment once every 7 days for the next month or so, or for the next year, or if you have like a governance proposal that needs to be executed without you manually triggering the execution, well, it's just not possible because it's not possible at the protocol level. And that's most of the problems that we see on other EVM chains. So how do they solve it today? So what happens is you have some kind of network, like a Gelato network or OpenZLim Defender, or you might have your own custom bot server somewhere to automate this entire process. And thousands of protocols have been using this for a long time, and it works, right? It works. But the problem is there is still some centralization risk that comes along with it, because you're still having to trust that other third party to execute your transaction at a specific point in time. If something were to go wrong, at 3 a.m. and your DeFi vault doesn't get rebalanced, well, your users might get liquidated for no reason, right? And there's also additional cost. In addition to paying for the gas, you're also paying some sort of recurring fees to have this off-chain service. And there's also some trust assumptions. You have to trust this centralized party or out there somewhere to do the work that you want it to do. And then there's also the infrastructure overhead. Someone needs to manage that server. It's just a lot of costs associated with it, right? It works, it solves the problem, but you're still trusting someone or something to call your contract, and you're paying for it. So how do we solve that on Hedera? And I'll let Michael talk about Hedera's scheduled service.
Yeah, so let's understand a little bit more about HSS and how it works. So it's a native Hedera service that allows transactions to be scheduled for future execution at the protocol level. There's no other third party involved in it, as Kieran had mentioned earlier. We schedule a transaction, Hedera stores that call data, and then at some point in the future, we have automatic execution of that wrapped transaction from the HSS, which is all really cool. But we could also do this from smart contracts as well. So we can now have smart contracts schedule themselves in other smart contracts, and that's done via HIP 1215. So HIP 1215 is a bit of a game changer for generalized scheduled contract calls, as the title states. It allows you inside your contract to make a scheduled call to 16B. We kind of mentioned earlier was a pre-compile that's been added into the EVM network to allow us to talk to native services under the hood. The HSS will store the transaction that you want to call in the future, along with an expiry date and some other metadata. When that time happens in the future, the consensus node picks up the transaction from the HSS and then executes it on the consensus node. So this is all happening on the network itself. There's no third party involved. What it allows us to do essentially is to have on-chain cron jobs, self-perpetuating contract logic, which allows, if a contract does something and it's a successful transaction, it can then decide to call itself again and recommit, which is pretty cool. Truly, you're going to get smart contracts at that point. We get fully autonomous smart contracts and zero off-chain infrastructure, which is really cool. Gives you, less technology to manage as you go along. So, as Kieran had alluded to before, there's ways to solve this in other blockchains, and it has been solved. We have keepers, the networks, and your own servers to do this kind of work. It has a lot of external automation. You need to know DevOps. You might need to know security. You have to do a lot of key management that's kind of problematic if you don't get it right. Additional costs and multiple points of failure. Whereas the Hedera solution is a lot more elegant and simple. You have a smart contract, it's funded, it can schedule calls, they auto-execute in the future via the HSS, and it all happens inside the consensus layer. It's native, it's built in, and there's no external dependencies. Okay, if you're doing the scavenger hunt, you know what you need to do. All good? Okay, so back to Kieran, and he's going to show us now kind of hands-on exercise on how to actually use this technology. Thanks.
Thanks, Michael. All right, thanks for the introduction to scheduled service. For the next part of the presentation, I'm going to be demoing deploying the contract. We're going to interact with the contract. We're going to look at it on the Explorer, how it looks like when you're talking about a contract that schedules itself in the future. Sort of like I try to use an analogy. It's almost like if a runner were in a relay race, the way that scheduled service works is the runner passes the baton to himself in the future across time. That's how I like to imagine it. That's basically what happens here. So I'm going to talk about the pattern to be aware of. And again, this is just a pattern, right? But It's super straightforward to understand how the mechanics work if you understand how the whole scheduling system works on Hedera. So the first thing that we need to worry about is, there's three different processes, three different stages as part of the pattern. The first is the initialization function, right? This is the function which you initially call to get the schedule started, and it will handle, things like, schedule, keep repeating this schedule like 15 seconds from now, and I want you to emit an event, I want you to do something, balance, pay, whatever it is, that is part of this function, this first entry point into the scheduled service. And what's going to happen is, and then the second is the worker function. The worker function is where the magic happens, because what happens is when those 15 seconds or 30 seconds, however much time you have passed in on your cron job passes, the consensus node, the network itself, wakes up your smart contract and then calls your smart contract with the function, with the call data that you gave it as part of the initialization function. So let me back up. So if you have on this worker function, if you may have a function that just emits an event that says hello Hedera every 15 seconds. So what happens is it emits that event, and then at the end, right before it ends, it basically schedules its next execution. Next execution 15 seconds from now. So, and then the loop continues forever and ever, or until your contract runs out of HBAR. So if you have a lot of HBAR in your contract, you do need to be aware of, you have this scheduler service running, and it's just going to keep running until you exhaust it, or coming back to the third stage, which is the function for stopping, because you want your scheduler to stop. Maybe like something happened, you just want to stop it midway. You can always restart it, but you also probably need to have a stop function to stop it midway. If you're running out of HBAR, you want to replenish that. Again, like if you run out of HBAR in the contract, it will just fail and it will stop the loop. So you need to restart the scheduler, but that's the pattern. All right, let's go back to the demo. I am going to open up this guide. This should be part of the prerequisites. If not, it should be in the same repository that we're using here. Just to reiterate, it is on Hedera Dev Dev Day tutorial Hello Scheduled World. You can go to docs and then guide if you want to follow along with the guide. But just to keep things simple, what I'm going to do is I'm going to walk through this guide and I'm going to show you how exactly you can deploy this contract and then interact with it and schedule and do all kinds of crazy stuff. All right, so first thing you need to have is obviously you need to have some testnet HBAR. So if you haven't, go to portal.hedera.com and then get some HBAR, your hex encoded private key, start with 0x. All right, so the first thing we're going to do is we're just going to create a directory first, so we can just start everything fresh. So I'm in this directory. All right, make it bigger. I'm just going to copy paste. So all I'm doing is creating the directory. I change it to the directory. What I'm going to do is I'm going to initialize this project with Foundry, with Forge. So it's going to initialize. If we look here. You see the live directory, that's all the dependencies, and then you have the test, and then it comes with the default counter, contract, and test. So I'm just going to remove all that first. Let me just open this on VS Code. Just for the sake of it, I'm going to open this also. The same one. So, all right. Just to make things simpler, I'm just going to do everything on the VS Code here, so it's easier to follow along. All right. So the first thing we're going to do is we initialized our directory with Forge. That's all dandy. I'm just going to remove these files that I don't need because I don't really need them. Again, just to make things simpler, instead of typing all this, I'm just going to copy paste. And I'll explain a little bit about all the code that I'm copying pasting. So for now, let's just copy paste. So all we're doing is we're setting our profile on Foundry. So we're gonna have an environment variable later, which is gonna define our RPC URL, and then this just comes with it. The remappings is more there for, because usually what happens is when you install a particular library dependency, it's under some, in this case it's lib Hedera smart contracts. And in order to make things simpler, I want to be able to import some on my contract with something like add hashgraph/smart contracts. So that's why we have the remappings here. But that's all. That's all we need for the foundry.toml file. Next, we're going to create our environment file. I already have an environment file, so I'm just going to copy that over on this directory. But you'll probably need to substitute this to your own hex encoded private key. Next thing we're going to do is we're going to load our environment variables locally, so we can play around with it through Foundry, so through Forge. All right, so next what we're going to do is we're going to install our smart contracts, system smart contract library directly in Foundry, so that we can utilize the Hedera scheduled service precompile, and that exposes a lot of the things that makes our whole smart contract self-executable, repeatable in a cron job manner. So let me just copy paste this. So this is going to install this locally. It may take some time. Next, let me talk a little bit about this. So what we have here, and this is one of the key functions, and we'll show this in the code later, but this is the core function that is going to be rescheduling. So here on the address, this is the contract that you're asking the protocol to call. So in our case, because we have this cron job that's going to execute its own function in the future, the two will be the address of the smart contract itself. So it's sort of the relay race analogy that I told about earlier. The expiry second is when you want to have the network call your function 15 seconds, 30 seconds, a week from now, 2 weeks from now, whatever it is, right? And the gas limit, you probably want this to be enough that whenever the smart contract calls itself in the future, you have enough gas. Otherwise, it's going to revert, so you don't want that happening. And we're going to see that. We're going to see how to set that later. And the value, usually for this use case today, it's 0. But if your function requires some kind of value, you're sending hbar, you can do that. Call data is where majority of the encoding happens. So in our case, we're going to have a function that's just going to emit an event and then schedule itself in the future. So all of that is going to be encoded, and then we're going to pass it in to this schedule call function. All right, so let me copy this first, and I'll explain a little bit about the structure of this contract. There it is. All right, let me create a directory, file called hello scheduled world.sol, and then explain a little bit about this here. Make it bigger. All right. So here, let's do this. Don't need to do that, but let's just ignore that. We don't want the linter complaining. All right, so here first we are importing Hedera scheduled service from our system contract library. This is the full path here, but again, you can feel free to check out. You can check out more about all the functionalities that Hedera scheduled service exposes. One of them is the schedule call that we talked about, but there are some other functions as well. You're able to have a function. We don't have that in this demo, but in the second demo, where you're able to check exactly the time slot that is going to be open to execute your call in the future. That way, whenever you can know exactly ahead of time that your function is going to be executed at that particular time. So here I'm setting the gas limit to be 2 million. That's fine for this case because, as we know on Hedera, as of recently, no matter how much gas limit you send in, it will only consume the gas that it actually uses. So you're not going to be charged for 80% like you used to before. So that's good. It works for this. We have our constructor, and then we have our receive function. The reason is, someone has to pay for the scheduled transaction, and it's the contract paying for that. So you need this receive function so that you can send, and also constructor to be payable. So you can send some HBAR to your contract address, and then the network, when the network calls your contract later on, 15 seconds, 30 seconds, it will just reduce that that amount from your contract balance. So this is the meat of the project. So there's the initialization function that I talked about earlier, which is the entry point, right? We have the message, hello Hedera earlier in our demo interval, let's say 15 seconds, but you can really go far in the future. And then this is an internal variable that is going to keep track of whether the scheduled current cron job is active. If it's false, then it's not going to execute. So, and then we have this schedule function. It's an internal function. All it's doing is, as I was talking about earlier, we have this print message function. Let's just look at that. So this is our worker function I talked about earlier on our pattern. So all it's doing is it's checking, okay, is active, is the cron job running? Like, am I supposed to run it? Okay, if it's active, then we go ahead. And then it's going to emit an event with the message that we passed in initially. And then it also includes the timestamp, so we know we can check it later when it got executed. And then the last thing that it does, remember, it needs to be able to schedule its own future call. So it just calls schedule again. So like we're re-entering here to basically encode all the message, all the data that print message requires, and then we're passing this data in to the schedule call function. Remember I talked about schedule call function here. It takes 2 expiry second, gas limit, value, and call data. That's exactly what it's taking. So here we're passing our own contract. You can pass in another contract, that's fine. We have the time, which is whatever we set it. Gas limit, we're passing the gas limit. 0 in this case, but it may be different for your case. Data is the actual data of the function that we're trying to execute every so often. And then last but not least, if it fails, then it's gonna say schedule failed, blah, blah, blah. And that's it. Like, it is under 50 lines of code, and this is all you need to have a cron job running on chain. So the smart contract, the protocol wakes up the smart contract executes its own logic, and then the last thing it does is reschedule itself whatever time in the future that you set it. That's all it's doing, right? So let's go ahead and let me come back here. Let's go ahead and build our project. So Forge build, and compile. So here I'm using Forge to basically deploy the contract. If you're not familiar with Forge, here all I'm saying is, okay, Forge, create or deploy this contract that is on source hello scheduled world.sol. That's the contract name, and then we're passing our RPC URL, which is set in the environment variable, and then let me just do this just in case. And then you're passing the private key because you're signing with your account. And then I'm gonna send some ether. In this case, it would be HBAR because that's just the syntax that Forge has. So ether, just remember that this is just saying 10 HBAR, and then broadcast is just used to broadcast the transaction. So let me just copy this code and deploy this contract. All right, so we have our deployer. This is our account that I'm using to deploy. This is where it got deployed. And then there's a transaction hash. We can check this really quickly here. So if I go here, here's our contract. All right, well, I can't see any bytecode here, the actual source code. That's because the contract isn't verified. We're gonna solve that pretty quickly here. So first thing we wanna do is, and we're gonna use this later, so I probably wanna set this variable, contract address equals this. And then, again, this is an optional step, but if we want to see what's going on, like if we want to, trace all the events, like all the data, we probably want to verify it. So this is a helper script. It's all in the documentation, but this is a helper script that generates a metadata.json file that you can just feed in to Hashcan. And it works with Foundry and Hardhat both, and it's a really easy way to generate the entire metadata. It works for multiple contracts at the same time. Like it works for all use cases. So I'm just going to copy this, and all it's doing is making this verification the metadata generation script available, so to be executed. And then I'm going to generate this. All right, now you see here, this is the metadata JSON file. So I'm going to do hello metadata downloads. All right, I'm going to quickly verify this. There it is. Got verified quickly. Now we can look at the source code, ABI, source code here. All right, now we're ready to execute our function. So next step is, so we're using Caster. We're dealing with Foundry today, so we're just going to be using all Foundry and Force related commands. But all this is doing is it's calling our initialization function, like schedule message. We're passing in hello Hedera every 15 seconds. We're passing in our RPC URL and then the private key, right? So let's go ahead and execute that. All right, got executed. We can check the calls tab here. All right, so we look at the trace. Okay, schedule message, it got scheduled. Let's wait a little bit here, 15 seconds, and then we'll jump back and refresh the page. There it is. Oh. Let's go to trace. So this is the first call. So we see here, this is the contract address. We see here like this scheduled transaction got executed. Usually these two addresses are different, right? Because someone else is calling it. But here, in this case, it's the contract for the from address, and then it's the contract itself for the to, because the contract is calling itself with however many, well, and it is executing this print message. That's all it's doing. And if we look back again and again, you see here, all of these are getting executed. Again, this is my account. I'm just executing locally, but every 15 seconds, we look at the events tab. We see hello Hedera, timestamp is there. Every 15 seconds, we have a working code. We can also check something here pretty quickly. So all this is doing is checking whether the cron job is active. We're calling the is active public function of the contract. Same thing here, like what's the message? Hello Hedera, and then we can even check the interval currently. And then if you check the balance, it should go down every single time. Now it's down to 1.5 HBAR. That's probably because it got executed and you spent all that HBAR already. So, and then there's also a function to stop scheduling. Let's go back here. Last thing. Here you see that the last transaction, it says, well, it failed. Why? Because insufficient pair balance. Because we only sent 10 HBAR, and we ran out of HBAR pretty quickly because I'm executing it every 15 seconds. You can see here, all of these are scheduled transactions that got executed. Eventually, it ran out of HBAR, and then it reverted. Now, if you wanted to reschedule it, all you have to do is top off this contract address, and then call the start scheduling function again, and then you can start the whole process one more time. But we're not going to do that. All right, let's see what else. I think that's part of the demo. Let's jump back to, oh yeah, one more thing. So I'm just going to quickly show a demo here. This is an entirely different contract. This is an ERC20 contract that has an airdrop functionality. So, you can set it so that every 20 seconds, I'm going to mint X amount of tokens, and then I'm going to use the pseudo random number generator precompile to basically randomize and retrieve whatever address that is part of the registered list, and then it's going to mint it and then send the ERC20 token to that. And you can set it, and you can look at the code later, but these are the kind of things that is possible, right? Like I'll quickly go ahead and execute this so we can see this in action. Where is it? All right, we need to first register for airdrop, so let me go ahead and register. All right, asking for MetaMask. I'm going to choose a different account after this, so we have two accounts. Sure. going to register it one more time. All we're doing is registering for the airdrop. So we have two addresses, so we can quickly check it. Right here, get recipients, we have two addresses, and then we can see, okay, let's start the schedule here, start the airdrop. It's default values that I have set here, but we do this every 15 seconds, so we can quickly see it. Max 5 drops is after 5 times, it's going to basically stop. So these are the kind of logic that you could have, and I have an optional message, so let me just start the airdrop so we can see it in action. Who gets the airdrop? Right, let's go ahead and look over here. Oh, I should go to my other wallet actually. Because I tried to call it from my other account that does not have access because I'll show you something. We look at the code, we are using ownable, and only the owner can start the airdrop right here, only owner. Let me go ahead and call it one more time. Start airdrop, just gonna do 20 seconds. All right, that should be successful, there we go. All right, let's wait 15 seconds, it should go pretty quickly here. All right, let me refresh the page. There it is. Wait, no. Is that the one? Yes, that is the one. So from to it's the same, and we're calling it's called execute airdrop. Let me go back and check who actually got the well, let me just check my own. Okay, this address got whatever 303. I can't think the number tokens airdropped. But this is the idea, right? These are the kind of things that is possible with scheduled service. So let's jump back to our presentation and end it. Okay, go back to slideshow. All right, we saw the scheduling pattern. One last thing I wanted to mention, this is the entire flow, right? We deploy the contract, we call it schedule message, initialization, the Hedera scheduled service stores it on the network, and then after 20 seconds or whatever time you give, the network will wake the smart contract, it'll call the smart contract will call itself, and then as part of the last thing that it does, it reschedule itself sometime in the future, in this case 20 seconds. So it just does that forever and ever and ever. And we didn't even need any kind of off-chain infrastructure. It was all done on-chain, possible directly at the protocol level, and this is magic. All right.
Okay. Thanks, Kieran, for that demo. So obviously we saw a few different options there, from something relatively simple, emitting a message, to something a little bit more complex with airdrops. So it kind of begs the question, is like, what can you build with it? I mean, right here we've kind of had 5 kind of general ideas of where it might kind of fall into useful use cases. So security, time lock multi-sigs, or dead man switches on contracts or functionality are really good use cases. In governance, token vesting, voting deadlines, and as we also said before, auto-executing proposals.
Look at the pink
really
boxes.
The schedule service. DeFi, lots of great use cases in there. Automated liquidations, auto-compounding yield distributions. Usually that's done through some kind of do work as people transact. It kind of piggybacks on, but you don't need to do that anymore. You can have a true yield happening at a certain time. Infrastructure, Oracle's a great idea for this as well, and recurring payments. Some really good use cases. And then gaming, kind of as what we had that demo there, was like scheduled NFT reveals, random drops. Kind of it adds gamification into it as well, which are kind of really good use cases that. Using the Hedera schedule service and the random generator kind of together to create kind of compelling, use cases. So, kind of trying to sum this up. So, your competitive advantage using Hedera and being a developer, you can offer true automation on chain, lower costs for each of your transactions and any the tools that you kind of deploy. Higher reliability. It's a protocol level guarantee. It's stored on the consensus nodes and it's executed on there. There's no third party to kind of worry about for any kind of connectivity or kind of issues. Balance with that as well, there's other zero infrastructure costs to you. So if you have a DApp or a project or that, you don't need to worry about infrastructure in AWS or DevOps to kind of have this thing working. And then also full transparency. Everything is visible on chain, so people know when things are going to happen, and you can see that and change that as and when you need. So, okay, you've obviously seen some from today, and you can continue this journey and learn more. The tutorial that we had today is available at the link there. If you want to learn more about the HIP, the specification is available on the HIP site, and then the code repository for today is available from the QR code there on GitHub as well. Okay. So, thank you all for listening to us for 40 minutes, and thanks Kieran for such a great demo.
We have 5 minutes, so if we have any questions, we can take them.
I don't know that you guys are going to be able to hear the Q&A.
You
At
can
least not
see
the
the
audience
event, you just
questions.
can't make anything out of it, but it's not verified, so it doesn't know how to decode it. So. The question was, if the contract is not verified in Hashcan, can you see all that stuff that we see on Events tab? You can, you just see the events, you can't actually decode it. Sorry? The start button? Oh, that's also one of the things, yes. The contract needs to be verified. That's why I had the first demo where I can do it from the command line if it's not verified. If it's verified, I can also use Hashcan. And in the future, as mentioned in the earlier talk, we are working on an EVM Explorer, so that should be easier to navigate.
Good.
All right, that's it. Thank you, everyone.
Thank you, everyone. Thanks for your time.
So my camera is in a pretty good spot. I'll probably leave it where it is. Probably got about 5 minutes before the next presentation. What I wanted to say there, I didn't want to cut them off because, that's their presentation, not mine. But by the way, music's loud. Nothing I can do about that. I'm expecting you guys to see NFTs and tokenization hit the gaming market. So I have a prediction. I've been calling on the channel a couple times now. I think Grand Theft Auto 6 is going to have NFTs in the game. If it's not going to be NFTs, I think they're going to make their own stable coin, or maybe even just like a Grand Theft Auto coin. We'll see how this all plays out, but I think it's going to go in that direction. It's kind of like, in some ways, you already have this a little bit with if you play Clash of Clans, you buy gems. If you play Diablo, you buy crystals. If you play, you guys get the idea. Any game you play these days has some sort of in-game currency that you can buy with real money. This is just the next step of it, and this is a better model because it means that even if you don't play the game, you could, in theory, buy those points and then trade them for other things. So, just throwing out an example here, this is kind of where my mind's going with it. The Seattle Seahawks just won the Super Bowl, right? So imagine you're playing GTA 6, and the Seattle Seahawks make some deal with Rockstar. Sorry, I might be yelling in the mic here. The music here is ridiculously loud. If the Seahawks win the Super Bowl and they say, we want 50 Seahawk Lamborghini skins, those become NFTs that can then be traded on the market, and then you buy the NFT, you can either apply the skin to your Lambo in-game, or you can say, no, I'm going to hold on to this because it's a collector's item, and then someday, 5 years down the road, go on the marketplace and say, hey, I've got the 2026 Seahawks Super Bowl Lambo skin. I'm going to sell it for $5,000. And people are into that stuff. I'm sorry, I just got an error message on my screen. It said that my encoder maxed out. Can you guys still hear me? Kind of this is all kind of a dry run. I'm running off of the Wi-Fi they've got here, so it's not the same specs as what I've got at home. All things considered, I think we got a pretty good setup here. I've got my camera set up, it's mounted, I've got this mic. All of this is running through my laptop, by the way. I've got like 80 different wires. I almost wish you guys could see it all. I don't want to move the camera though. I feel like it's in a good spot and I don't want to adjust it. I like this. I think this is good. This is going to make it so that I can keep making content even if I can't always be at my house. If I go on vacation, I could bring this up with me, half-hour stream in the morning, just things like that. So this is a good experience one way or another. It's driving me nuts that this music is so loud, but like there's nothing I can really do about that right now. I'll definitely try to stream again when I get to the hotel room. And, you know, I'll be in the hotel so there won't be all these distractions or all this loud noise. But this is cool. I like this setup because, look, you know, I can post this to the Discord. So if you're on our Discord, just drop the 4-hour live stream and just say, you know, just scrub until you get to the spot that you want to find out about. And maybe I can spend some time putting timestamps into this. Because this is going to go for about another 4 hours, and I wouldn't expect anybody to watch all 4 hours of this. But when I post this to the channel, you can scrub through. You don't have to listen to my commentary. You can just go straight for the sauce, or maybe you want my update on it, because I might be able to articulate this in a way that makes it easier for people at home to understand. So, you know, your call. Say hey, bro says, send me the room number. You want to know what? I wonder if it's on my room key. I'll give you the spoiler. It's 420. Now, I'm not really... No, it doesn't say it on the room key. That's not really my style. I'm not a straight edge guy. I do have my vices. It's just I like things that make me go faster. And that's all I'm gonna say. I gotta be smart about this. Interesting. So you guys can't hear the music that bad. For me, it's like literally blasting in my ear.
Smart contracts. So thank you, Kieran. Thank you, Michael. Now we're going to cover a topic that a lot of developers run into fairly quickly when it comes to on-chain data.
All right, I'm going to let them go back to work.
On-chain data integrity, on-chain verification is important. And so let's cover how you can do verification on a very large scale and of a lot of items on-chain. For that, I'm going to welcome to the stage Hedera Merchant. So welcome, Hedera.
Thank you, Ed. Thank you for Kieran and Michael for the last presentation. So quick show of hands, who here flew in for Dev Day? Fly in? Yeah, me too. Turns out that flight you took could have not happened if it wasn't for systems like we're going to talk about today. And so as you see, these are real headlines that you see. There were actually hundreds of flights grounded.
This is going to be a good one.
Fake parts for our airplane, allegedly. And yes, there's also an eBay listing for a Boeing 737 emergency exit door. Now, can you imagine if this is what you saw on your flight the other day? And the description is pretty funny. It says, used with a small ding, fell on the ground, no big deal. But in a serious question, how do we prove that parts that airlines, automobile companies, buildings are getting are actually proven and to be real and is coming from the manufacturer? How does an aviation authority verify that the serial number on that door traces back to the actual manufacturing process? So we'll dive into that today. So my name is Hedera Merchant. Welcome you guys to Designing for Scale workshop. We'll try to do a batching 1,000 records on chain, and you'll all join that with me as well. So this will be a hands-on workshop. So we'll go through some concept first, and then go into the actual running it yourselves. Sounds good. Let's start. So the agenda quickly is that we'll talk about Merkle trees, we'll cover the concepts, who's already using these in the real space right now in the world, and why does this actually matter. and then we'll go through the workshop together, get our hands dirty with HCS, which is Hedera Consensus Service. We'll batch records, we'll anchor them on chain and verify them all together. And then at the end, we'll do a Q&A if needed. And if there is some bonus time remaining, I'll go through a way to run the network locally for you. So those who are interested, please stay at the end. And then if you have questions, we'll wait till the Q&A, but I'm excited to go down this with you guys. So before we begin, let's talk about what does it mean to actually batch 1,000 records on chain. Why would you even need to do this? And if you think back to our airplane example, just put your shoes in an aeronautical engineering firm. You manufacture a part that could be a door, that could be those engine parts, the cockpit parts, that could be the wheel itself. But you want to stamp it, you want to prove that it's yours, and then when you ship it to Boeing or SpaceX or whoever it may be, every part of that life cycle is generating an event. You have your quality checks, your manufacturing itself, you have shipping, delivery, installation, and that's all for just one part. Now take a step back, and that could be 20 to 50 events just for one part. You added the entire component of that plane, you're talking about thousands of parts, now you have a really large data set here. So you want that track, you want it to be provable, and you also want a regulatory authority to actually be able to check it themselves. But when you think about submitting all of those transactions on chain, that becomes pretty expensive. And I think the best way of going about that is Merkle trees. So before we begin getting to that, does anyone know what a Merkle tree is? Show of hands. 2 people? Great. So essentially a Merkle tree is a hash of hashes. You start with your data. At the bottom here, you start with your data, you hash it, and you keep combining these hashes into pairs until you end up with one root. That's your single root hash. And that single root hash is, imagine, your single source of truth. So through this diagram here, you have your data. That could be anything, JSON objects, that could be transaction records, that could be airplane manufacturing parts, sensor readings, anything that you need to track, that is your data. And then each piece is hashed via SHA-256, and those hashes then become your Merkle leaves. And then moving above that, you'll hash each of those hashes. So hash 1, 2 becomes hash 12, hashes 3 and hashes 4 become hash 3, 4, and those become your Merkle branches. And as you can see, you work your way up to the root. And then those 2 hashes together, hash 12 and hash 34, then are hashed again to become hash 1234. That is your Merkle root, and that is the one single 32-byte hash that represents all 4 pieces of data. Now you can imagine when there's more data, you have a few more hashes, but the end goal is the same, to get one Merkle root. And there's also one key insight, is that if anything is changed within that data, that root will completely change, and the fingerprint of this entire batch lives on that Merkle root hash. Sounds good? And just want to go through some current use cases that are out there. You see GitHub, and now GitHub is using Merkle trees for every commit. Every commit on Git is a hash that represents its parent, and that enables integrity checking and syncing. Microsoft SQL Server uses Merkle trees for ledger tables. And the bigger one that we want to showcase today is Google Trillion. Now, Google Trillion is an open source library for transparent and cryptographically verifiable data source on Google. As you can see, it's got about 4,000 stars, about 420 forks, and almost 1,000 projects are using this right now. And teams like Apple, Google, Cloudflare, DigiCert, and Let's Encrypt are all using this from Google Trillion. And the best thing about this is that these projects here are using this as a certificate transparency log. So every time let's say Let's Encrypt is issuing an SSL certificate, that is going into a Merkle tree. And this is kind of how you see almost the Internet Certificate Authority kind of being honest. So when we talk about Merkle trees for supply chains, for financial auditing, we're building on a battle-tested infrastructure that the biggest tech companies in the world already rely on. And so we've already discussed a little bit about the properties of a Merkle tree, but essentially they have a binary tree of hashes, the leaves are hashes of individual records. Those branches that you saw are a hash of children concatenated together, and that single 32-byte root is representing the entire batch. But what I'd like to showcase here is this table. And I'm sure that your eyes are already glued to what happens with the pricing between without batching and with batching. So as you can see, the last one, 100,000 records, without batching would cost $80 on HCS. Now, with batching, just like 10 records of 10, 100, 1,000, 10,000, and even 100,000 all cost less than a tenth of a cent. That's absolutely incredible. Your savings is to the right by 6 decimals. That's kind of bonkers, if you ask me. And this proof size grows logarithmically, so that's cost is staying flat. So that's the entire point here. And you're kind of curious, hey, how does Hedera fit into all of this? Well, Hedera has the HCS consensus service on Hedera. It's essentially a public and immutable log, messaging log, that when you create a topic, you can then submit messages to it. And that's it. It's simply is that it's powerful because not only does it give you a message log, but it has native performance for about 10,000 TPS. You can amplify your trust with validating data in multi-party databases, notary services, or anything that needs transparency with shared infrastructure. There's guaranteed order. You can get fair total consensus order there with accurate timestamps, a running hash of the topic, and plus a state proof that guarantees correctness. And then obviously we have the ecosystem integrations, things like the Hyperledger Fabric. And at the bottom you see there's a little flow. I think that flow is absolute key to what HCS actually is. You create a topic, you send messages to that topic, those messages get processed with consensus there, and that's exactly what HCS is, and then anyone can audit it, and that's the best part. And I love this quote by Brian Gross from IBM Blockchain, simply putting, Hedera is making a meaningful contribution to furthering the capabilities of distributed networks by exposing this capability. So we'll move forward here to the demo here. So if you guys want to follow along, there's a GitHub repo here for the best workshop, because it's your best workshop for the day. So you guys will try that out, and then once we have everyone taking care of that, we'll give it a go. Beautiful. Awesome, thank you so much. And then, so I'll go through the setup and the scripts that you'll go through, and then I'll go through at the end so you can see what it looks like. But once you get to that repo, you can then clone the repo as you would, cd into the directory, and then run npm install. Then you can just copy the environmental examples and put in your own. And once you have all that taken care of, we can then get your credentials at portal.hedera.com. If you don't have an account, please make an account, and then you'll show your ID and your key. So the ID you can copy paste over to your env file that you just copied over, and paste it into the 0.0.xx part for your ID, and your operator key will be under more details. So just get that 302 private key, copy that over, and paste it in there. The topic ID will leave blank for now, and then we'll get that in just a moment. And the network should be the test nets as you see there. Beautiful. So the first script we'll run is the create topic. This essentially is creating your own personal topic, your own message. And once it's created, anyone can read this message or any messages on this topic. And then when you submit a message, you are then paying for that message from your account. When this runs successfully, you'll see the output there, as we have there, a green check mark with your ID, the hashscan link, and we'll go through this all in just a moment, but just showing you what it looks like, giving you a little bit of knowledge before you run it, so you don't know, so you know what you're doing, you know what you're getting yourself into. The next script is you're going to compute the Merkle root here. By default, this uses a batch of 10, but if you're brave enough on your computer, you can actually update this with a dash dataset batch dash 100 or 1,000. You can go more than that, but those we recommend for the first go through of this demo of this tutorial. And what's happening under the hood, it's first loading that record that we have from the file, and then each record is a payment transaction that has an ID, a timestamp, a type, and a payload, which is all very important. The second step is it canonicalizes each record, and that's just a way of saying that the JSON keys will be laid out deterministically, only because when you have a record, if it's changed around from the record, it'll have a different hash key. So it's all done in the same way, canonicalized, so it always has the same one. So A1 and B2 may not be the same hash as B2 and A1, so it's ordered correctly, so that always happens the same hash. So all these are hashed, obviously, with SHA-256, and then now we're starting to create that leaf, that hash. So you have the Merkle tree being built up from the bottom, and we'll hash those bottom ones together, we'll pair those again, and we'll keep hashing it until we get to that Merkle root. And then you should see that root hash in the terminal as I have down there. It's that 64 hex character, it's about 32 bytes. Whether you have 10 records or 1,000, that root is always going to be the same size, and that's the entire magic that we're going to show off today. So the next one is the third script, which is the anchoring root on HCS. This is where we can now put this on chain. What this script does, it recomputes the root locally on your computer, and that's more of a check for integrity. Then it wraps that into a structured JSON root, as you see there. So you have your schema, your worker root, your record count, whether it's 10 or 100, using the hash SHA-256, and then it'll also confirm with the batch JSON that you have. And once you have that, you'll get a transaction ID and hash handling once you run that script. And then we'll show what that looks like in just a moment. And then there you should have, a 260-ish byte message representing all of the proof of all those 10 records, 100 records, whatever it may be, or 1,000, or even 100,000. And all that is cost of less than a tenth of a cent. Now that it's on chain and now it's timestamped with consensus time, it can never be changed, and it's there for the world to see. So that's exactly what we're trying to go for. And when you do this, before going to the next step, you want to maybe wait 5-10 seconds so the mirror node can then take in that information and index that message. So the next two scripts are going to be verifying the batch and then verifying a single record. So the first one is verifying the batch. So you'll run this script for verify batch.js. What's happening here is that it's recomputing the Merkle root locally with that JSON file. Kind of the same pipeline as before. We have the characterization of it, the hashing, and the building of a tree. And then is now querying the mirror node, which is a free public API. There's no auth required, there's no smart contracts, there's no tokens needed, and it's all fetching the latest message from the topic that you've submitted to the HCS. It parses that anchor message, and then what it does is it's pulling the Merkle root that's stored on chain, and now this is the cool part, it's comparing the local root that you have on your computer versus that on-chain root. And once you get that, you'll have the bottom right, you have a green check mark passing that, yes, these two are working together, there's the same thing. And the best part about this is that anyone can verify this. Anyone, anywhere. The mirror node is free and public. You don't need to trust the person who did this. You don't need to trust the special, you don't need to get special keys. You don't need special permission. The Hedera network is that source of truth. And the part that might be crazy is that if any one particular batch has been tampered with, one byte, this checkmark will not be there. So you know something has been tampered with, something is going wrong, and I think that is the most key part of this whole situation here. And then going back to our airplane example, right? This is how we can prove that that door isn't from an eBay listing, but actually from a manufacturing firm. So you check that serial number on that door against the Merkle root here on HCS, and if it matches, it's real. If it does not match, something's been tampered with, and you can then check without going to find the manufacturer. You can understand what's happening here, and Hedera offers this service to you for free. And then last thing we'll do here is we can kind of check on one single record here. So we can run the script, and it's defaultly going to batch 10 and the fifth record of this 10 record. Maybe you don't want to download all 10 records or 1,000 records. So this way you can only just check one record to make sure that you can get to it and check it. Maybe the other records are maybe confidential, so you don't have access to them. So this is helping you get that one record and checking it against on-chain. So here we'll use actually a Merkle proof. And a Merkle proof is just a path of sibling hashes from your leaf up to the root. So for a batch of 10, it's only about 4 hashes. For 100 records, that could be 7 hashes. For 1,000, it's about 10. And so the verification works is that you start with your record's leaf hash. Then for each step in the proof, for all 4, you have a sibling hash in its position left or right. And if the sibling on the right is yours, you hash that one first, then the sibling, and the opposite. If it's on the left, sibling first, then yourself. So you're always having a pair partner here to root all the way to what is anchored on HCS. If you have a scavenger hunt, feel free to add that in now. Beautiful. And so what we'll do is I will showcase the code real quick and show you how that works. So just give me just a quick second. So yes, so here now I have the first record. What I did was I've already added this topic to my env file. Let me make this a bit bigger. So I've done the first one, as you can see, and it gave me a topic, which I've added to my ID. We'll then run the second compute root. I have it as batch 100. So as you can see, it's loaded 1,000 records. It's canonicalized and computes with leaf hashes, and now I have this root that has my entire records all in one place. Then we'll go into the third one, which is the submitting the anchor. And once this is built, you can kind of see here that I'll get the hash scan link, so we can kind of go that right now. It looks just like this. And I can go to messages, and I can see that my message is now here on HCS. Beautiful. And then we'll verify the batch together as well. And you can see both that the mirror node that I have is matching my local data set. My ID is confirmed there as well. And then I'm interested in just doing one batch for a single record. This one's saying data 10, but I think that's okay. I think this is because it's defaulted that way. But even if that's the case, it's still checking that the root locally for that one single hash is now matched to the one on chain. So just to kind of go back to what we were talking about, just one second. So we've kind of learned 5 things here. That the first is the cost problem. We're just trying to store individual records on chain. It does not scale. So we want to get 100,000 messages on HCS without batching would cost $80. With batching, less than 1/10 of a cent. To do this, we'll use Merkle trees to enable this batch verification. You can kind of hash everything down to a single root, and the proof sizes are growing logarithmically. And then HCS is the perfect anchoring layer. It's public, immutable. It's a message log with consensus timestamps. Low cost, high trust, very ideal here. The fourth one is that you can verify entire batches and single records cryptographically without downloading the entire batch, which is great for storing data and not storing excess data. And the fifth thing is that we learned is that the mirror node is free and public, so we can then verify with no keys, no permissions, just having the trust required from the network. So yeah, and then I think we have a little bit more time, so we'll kind of discuss a way to run the network on your own computer. But before we go into that, any questions that we have? Fantastic. So I want to talk about Solo. So this Solo is a wonderful tool. I've been using it, a lot of people have been using it as well. This is a way to kind of test projects without having to get testnet tokens. It's a CLI tool, and so this repo you can get access to. I would suggest you guys going through this in your own time. It takes some time to set up, but it's actually fantastic. It's a CLI tool that can run a consensus node, a mirror node, a JSON RPC relay, all inside a local Kubernetes cluster. It's just fantastic. I love messing with it, and people have been getting a lot of fun out of it. And so just a quick idea of how to install it. If you have these requirements, Node.js to 22, Docker Desktop, and you have Mac OS, Linux, and Windows, and you have a 12 gigabyte RAM, 6 CPU cores, all that's what you need to kind of get it started on your laptop and devices. I suggest you try it out. And then the instructions to install it are on the repo, but essentially you're just going to set some you'll set some environmental variables. Once you have that, that'll take the longest time. Once you run it and deploy a network, that could take about 10 to 15 minutes or so. So just be mindful of that. And then you can do a quick prompt to verify the deployment, and it'll probably look something like that on the right side there. So we'll have this out for you guys if you're interested. And then the setup is pretty easy. You can then run this same demo that we saw here, and then just change the network configuration on your ENV to solo, and then run the same setup, the same 5 scripts, and then you can do this on solo, and you'll see that you can run the entire network from your own laptop, and I think it's magical. So you can then run these whenever you get a chance, and run those 5 scripts again. And this is a quick recap of what we did today so far. That's a wrap, actually. So thank you all for being here. I appreciate you guys' time. I'll also be around. If you have questions about solo for XCS, I'll be around, so give me a shout. And thank you for your time, and enjoy the rest of the day.
All right, here comes the music. So I had it typed out in the live stream chat, but just to kind of add some further clarity to that. If you hear about Songbird, I know some people have asked me about Songbird. I don't even think you can buy Songbird, but don't get into a situation where you're trying to. You'd be basically throwing money away. Songbird is the test net for Flare. Now, I haven't used the test net, so I don't even really know how you would acquire Songbird tokens. I've never tried. But if you do end up somehow getting them, if you paid for them, you bought test tokens. There's no value, at least no monetary value, anyways. But Songbird's used to test everything that we do on Flare. So before we had Flare assets, before we had delegating, wrapping, all that fun stuff, all of those things were tested out with Songbird first. Just in case you guys didn't know that part. So the Ripple conference is, I want to say, April 30th and May 1st. So technically not at the same time as the HBAR conference in Miami, but I couldn't go to Miami, or I couldn't go to Vegas and then straight to Miami. That would be too much traveling for me, at least at this time. So if I'm going to go to one, I'll probably go to the Ripple one.
All right, everyone, we're just going to take a quick 20-minute break. And so we'll be back here, and we'll dive into interledger interoperability. So
that's a fun topic. Well, since we got some time to kill, you guys want to see my setup? I've got wires everywhere. I mean, this thing is almost a safety hazard. I'm almost nervous to be doing this, so just got wires all over the place. This is my laptop, mouse, just cords. So there's going to be a 20-minute break. If you guys want to hang out in here, you can. But if you guys want to hang out here, you can. I'm probably going to take a break myself. I've been sitting here for almost 4 hours straight. So I'm trying to think of what to do about that. I got a little bit too much equipment to just like leave it and hope it's still here when I get back. I can't imagine in this environment it'd get taken, but I might at least go get a water and watch my laptop like a hawk. And I can't imagine anyone's going to try anything in a public space like this, but I am going to step away. If you guys want to carry about your day, no hard feelings. The next speaker is not on for at least 20 minutes. So if you guys want to do something else, pop back in about a half hour. We'll still be here. Pass a hat for a cord management class. I have it a lot better at my house, trust me. I have like zip ties and all that. It's just, I don't have any of that here. But there's so many, there's power cords on power cords. I have to have a power cord for the camera, the laptop. I guess that's about it. Yeah, I guess that's about it. I technically don't need the laptop plugged in, although you're running on borrowed time if you unplug that. The camera has to be plugged in because the camera battery lasts like a half hour. So I have a cord. I have like a dummy battery pack in the camera that allows me to plug it into walls, but that one nothing you can do about. And then the MacBook Pro doesn't come with a what do you call it? They don't have like almost any ports on the MacBook Pro, so I had to stick a docking station on this thing. They are very slim though. All right, guys, I am gonna grab some water. I'll leave the stream open. I'll leave the stream open. If anyone tries to do anything, just yell at them. Be back in like 30 seconds. I'm gonna go do some networking. Just watch my stuff. This thing resumes in about 10 minutes, so I'm just shaking hands, saying hi to people. Be back in like 10 minutes. I doubt anyone's stealing my laptop. I can see it. Plus, look at the stream on my phone. I'll be back in like 10. still live here? Make sure. Alright, sweet. Hey, you guys are still here. I think the break ends in the next 5-10 minutes. This place is kind of cleared out a little bit. I guess that's what happens when you have a, like a almost like a 10-hour day. I got here at 9, and it's currently 3 o'clock Colorado time. My body is all messed up. My body wants to think it's 5 o'clock, but it's really only 3. I'm gonna fill my water one last time, and then I'll be back to chat with you guys. Get some of those jalapeno pecans. No, they got new snacks out. They've been pretty good about the food here. I mean, there's got like a rolling buffet worth of food all day long. I'm actually surprised this was free. I don't know how. I have to imagine they didn't think just a random guy was going to show up with a camera. And most of the people here are like business partners or like companies trying to do partnership stuff. So I'm just sort of like here. But no, that's fine. I'm going to grab my water one last time, and then we'll get back at it.
Hedera Dev Day will resume in 5 minutes. Please take your seats, settle in, and get ready for more building. Hedera Dev Day is about to resume. Please take your seats.
All right, I did get one more of them pecans. They're good. I don't know how to explain it. It's like spicy. It's like good. I don't know. I like it. How am I liking the mile high altitude? Huh. I haven't even noticed it. I should go. Oh, I didn't pack any gym shoes. I could go for a run tonight, but I can't run in boots, so I won't. But I don't know. I do so much cardio. I don't want to kind of like blow smoke up my own
Please
ass,
join me
but
in welcoming back to the stage
I don't know that the
RMC,
altitude would
Hashgraph's Head of Developer
affect me that
Relations,
much.
Ed Marquez.
All right, everyone,
No,
welcome back from
Stav
break.
asked if I brought my
We're gonna resume
snowboard.
with our hands-on
I'm flying
workshops,
home
and
tomorrow
now we're gonna
morning. This
dive
is
into cross-chain development
just a
and how
day
Hedera
trip for
connects
me.
into the multi-chain ecosystem. So for that, please
I
join
didn't
me
renew
welcoming
my
to the stage
ski
Michael
pass this
Garber
year.
and Jake Hall.
Okay, they're back on, so I'm going to turn the camera around and get this thing back to it.
So out there are thousands of blockchains. We all know that, right? And of those thousand, maybe 100 of transacting any meaningful value. So in the future, where the world will be tokenized, right now we're sitting at about $2.3 trillion. There's $1.5 quadrillion, $1,500 trillion left to be tokenized. When that is tokenized, all these applications are being done on different chains. So how do we communicate that value without being stuck on our own islands? That's what this talk is about. Thank you for joining us. My name is Michael Garber, and I'm joined by my colleague Jake Hall, and we're going to talk to you today about cross-chain development using Layer 0 on Hedera.
Yeah, exactly. So, sort of a quick breakdown of the agenda. First thing we'll be doubling down into is that problem statement that Michael just explained. Then we're going to be looking at the solution and how it actually works, a bit of the theory. We won't go into too much detail because we also then will go into an actual live demo where we can see that theory in practice. So if there's anyone around here who wants to start building using bridges, we've got all of the repos set up for you. I highly recommend coming over, join over, get your laptop out and sort of get engaged. There'll be about half an hour spent on the actual building process. And then we'll just wrap up with sort of key takeaways.
Yeah, and you should have gotten an email. If you didn't get the email, check your email right now. It should give you the instructions of what you needed to get. You need to get some Ethereum on base and some Hedera testnet, HBAR. Okay, so without any further ado, let's talk about the problem. How blockchains are like islands. So, if you've ever been to a foreign country, you know what a nightmare this is. So imagine you're Japanese for a second, and you live in Japan. You have your bank account in Japan. You go to visit South Sudan because you're interested in there. You want to get a cup of coffee, right? So you're in the cafe. You sit down. You have your cup of coffee. The waitress comes. You want to give her your debit card. Sounds simple, right? No, it's not simple at all. Why? Well, the reason is because the banks have never heard of each other, they speak different languages, and frankly, they don't exactly trust each other. So, how do we get around that problem? It's sort of like blockchains or like islands. And it's ironic because we started blockchain with the whole ethos that we were going to tear down these walled gardens. But in the process of making these blockchains, they each have their own currency, their own rules, their own economy, their own receipts, and in a sense, we created bigger walled gardens. There's nothing connecting with them, so in a sense, they're bigger walled gardens, blockchain islands. The tokens are essentially trapped.
So I think just to sort of summarize, like it's difficult to spend your Japanese currency, I think it's the Japanese yen, in South Sudan, it's also pretty challenging to leverage HBAR on Hedera with the ecosystem, the DeFi ecosystem on base, and vice versa. Or you can't very easily buy an NFT on the Hedera ecosystem using Ethereum ETH. So the real question is, how do we connect these islands? How do we improve that liquidity flow?
It's about to say the
and
word
reduce
interoperability.
silos
Just watch.
which naturally occur, naturally rise out of these fragmentations.
So the solution is connecting the islands with bridges. And in the past, bridges were done with two custody contracts typically. There was a contract on the source chain and a contract on the destination chain. And then there would be an operator in the middle with keys to both of those contracts. And naturally, as a result, billions of dollars has been stolen. But thankfully, new protocols have been developed, and at Hedera, we support all the major ones that haven't lost a single dollar yet. Billions and billions of dollars have been transacted, not a single dollar lost. The way they do verification varies slightly from each other. In layer 0, there is a decentralized verifier network that's witnessing transactions, and then a separate executor that's executing, passing a bytecode to a receive function. On Chainlink, you have an Oracle network with a reputation system, and on Axelar, there is an intermediate chain in between the chains to come to consensus on a message before it gets passed on. But this is a signal that we're sending to the market. We're saying, no matter what chain you're on, your chain of meaningful value that you're on, you can connect to Hedera. In a sense, it's like all roads lead to Hedera. And we're saying, come give us a try. See the power and the speed of Hedera. And when you do, you'll get to see the unique properties like fairness of ordering, which no other chain has. So how does it work? So in these next 3 slides, I'm going to go over a general flow of how message passing works with layer 0. It gets a little bit more involved, and if you want those really nitty-gritty, boring details, come and see me after, and I'll answer all your questions. But for now, this is a high-level overview, and hopefully it will be enough to give you guys the gist of how it works. So, how does it work? It starts with having we're going to do OFTs, an omni-fungible token. That requires a contract on a source chain and a destination chain. These are identical contracts. They have the ability to mint and burn. And then there is another supporting contract called an endpoint. There's also another thing that supports the endpoint. We're not going to talk about that. This is an ultralight node. We're just going to imagine that the endpoint is a immutable contract that's set up by layer 0, and it acts like a post office. But what do I mean by that? Well, if a user, let's say, wants to send tokens to themselves, let's say they're sending 10 cheese coin to themselves on Hedera for base. The user initiates a transaction, they send it to the OFT contract, the OFT burns that supply, and then creates a payload. That payload is sent to the endpoint, or like the post office. So imagine that the OFT has created a letter, and the letter cannot be sent without being first put in an envelope and stamped and sent off. So that's what the endpoint contract does. It takes the payload, or this letter, and it packages it up in a way, it's called a packet, and it creates a unique ID and then encodes the whole packet. So now we're off the island. We were on the island, now we're off the island. There is a decentralized verified network that is always listening through a WebSocket to an emit packet event coming from the endpoint. And when it sees that, it attests to seeing it and witnessing it. And it calls verify on the destination chain endpoint. And that creates a registry of a unique ID that's been seen and witnessed. When you set up these OFT contracts, you also wire in a configuration, and you say, if 2 of 3 of the deviants witness this, then your executor go ahead and execute the payload. So the executor is also connected to a WebSocket, listening to that same event, and it is checking the registry on the endpoint of the destination post office, and it's saying, do I see that unique ID? Has it been witnessed 2 of 3 times? The moment that it sees that it has been, it takes the payload, or the packet, and it sends it to the post office. It calls a function called LZ receive. And in reverse order, the endpoint, or the post office, unpackages that packet and gets the payload. It sends the payload over to the OFT contract, which decodes it and then mints 2 cheese coin to the user A on Hedera. So the important thing to note here about this is that there is no custody involved. and there's no middleman. Well, you might call the DVN and the executor a middleman. And Clipper is removing all of that, so that's wonderful. But it's all verified by independent networks, and it's executed by smart contracts. There's no custody contract involved. The contract is what you deployed or what the issuer deployed. And that is a high level. I'll now pass it over to Jake to do a demo for you guys. Hopefully you got a good understanding. Ask me a little bit of questions later. I'm gonna go around the room if you guys have any questions to get set up.
And if you are taking part in the scavenger hunt, turn your heads over. We've got the secret code on the screen. I'll leave it on there for a few seconds. But after that, I see there's a few people taking their phones out to jot it down. After that, yeah, let's get into the demo. So the scavenger hunt horizon, and let's take a look at the demo. So hopefully you've all received this email containing the prerequisite setup. I'll also quickly go over it just in case there's people who have missed it. So this is, I'm using the GitHub repository, which you can find over here at the Hedera Dev organization, and it's a repository called Template Hedera LZ app, or LZ app as we'd call it in the UK. And this is the application that you want to clone. So to clone this repo, we'll be going through it. Some of the other prerequisites that you need is you need to have a Hedera portal account. So if you don't already, you can just find that over here. We've got the Hedera portal link, and of course with it you can get your ECDSA Hedera wallet. You can just use the top one, and if you've got your own wallet, you can actually use the faucet to just sort of send 100 HBAR into your wallet address. You can do that as well. I'll be using the one that you get from the portal because we get a bit more HBAR, but obviously you need to take that private key. And also, another one of the prerequisite steps is you need to top up that same address, whichever one you're going to be using on the Hedera side. You also need to top that up with Ethereum on Base, which is the destination or source network we're going to be bridging to and from. So I'm going to assume you've done that. We'll get into sort of the actual demo, but the steps you can sort of find more information over here. And now let's get right into the demo. It's going to be quite straightforward. It's basically going to be compiling the smart contracts, following the README, and then we can see on-chain the actual transfers and the actual activity happening. So the first thing you want to do, can everyone see my screen clearly as well? It's all good for everyone? Should I zoom in a bit more, or all good? Okay, so the first thing you want to do is compile the smart contracts. And what that does is you can see in the contract directory over here, we've got a whole load of different contracts. This is the first chapter of the bigger EVM bridging application. We'll just be focusing on the first part, which is doing the process that Michael described earlier, transferring a token which is created both on Base and Hedera, and transferring it from Base over to Hedera, so bringing some liquidity in. All of the contracts are over here. You can see that we're, for example, using the Layer 0 OFT EVM smart contract. That does remind me, actually, before you compile the contracts, make sure you run pnpm install, which will just make sure you've installed all of the relevant dependencies required to run this. But we've got the My OFT contract over here. We'll be deploying this to both Hedera and to Base. And you'll see it looks pretty similar to a normal fungible token ERC20. It's because it is. It's pretty similar. It's just got its own sort of wrapper around it to make it compliant with the Layer 0 standard. But deploy the contracts, compile the contracts, pnpm compile. And then what you need to do is you need to deploy the workers, which are, Michael briefly alluded to this, the thing which sort of happens behind the scenes. Reason why you need to deploy these is it just makes it a bit easier for testing on the testnet. In mainnet, you would use the workers and executors that Layer 0 provide out of the box. So on a mainnet example, you would not need to do this, but for testnet, it's a bit quicker and easier to just have your own local validator network. And all you need to do for that is just run these deploy scripts over here. So this will take us through a few steps. It will deploy the DVN mock and executor on both of the chains. Just sort of click through enter. So that's deployed it using the RPC relays which have been configured out of the box. And we can see now it's deployed these two types of contracts on base and also on Hedera. So it's my address, the contract, the account which I've been deploying and paying the gas fee for. It's over here, and the addresses are over here. You don't really need to worry about these because actually we've got some out of the box. This source code automatically reads from the relevant contracts here. You don't need to worry about configuring this yourself. Just deploy it, and then the actual back end inside of our application will read from the right place. I'll pause for a second. Is anyone following along? I think there's a few. Yeah, how's it going? Installing. Okay. Well, I'm happy to pause for a second, just while it's going, and I can just run through what we're going to be doing next before actually doing it, so we can get caught up. But the next steps is going to be, well, we've deployed these sort of simple workers, this middleware which handles the execution and the packet creation. Then what we need to do is we need to actually deploy the fungible token contracts, the OFTs, on both chains. We'd be deploying a fresh contract here and using a mechanism called burn and mint, which is the best practice when it comes to doing bridging. You burn it on one chain and mint on the other, so you don't need to custody and lock the tokens on another chain, which then puts that at risk of someone coming in and stealing them. Then we'll do some wiring up, and then the actual fun part, transfer the token from base to Hedera or vice versa. How's the install coming along?
Some of these guys are installing the software, but I was just like, I'm just gonna watch along.
Yeah, so for the EMV example, it's super straightforward. Just pass in one private key. Make sure it has testnet HBAR and testnet base Sapoli Ethereum, and you can just use the default JSON RPC relays. Hey man. Sorry, say again?
What does step 3 do?
What does step 3? Why? Okay, good question. Yeah. So somebody just asked, what does step 3 do? Why are the OFT for the simple workers? Basically, what this does is it essentially tells these executors over here, because we've just deployed them fresh. They don't have any context. We've just given them. This is sort of the scaffold for the interoperability to work. We need to let them know which token is going to be, which token is it going to be transferring. So this is basically a config file. We can take a quick look at it over here. Asset OFT. Essentially, we pass in, okay, what are the chains that we're going to be working with? What's the ID for the chains? Because each chain has its own sort of ID within the layer 0 context. We're just letting the executors know you're going to be working with Hedera and base, and this is the contracts that you're going to be working with. And you can see over here, actually, this is where we've got a, it's like this is fetching all of the metadata. For example, what is the metadata for the base network? What's the metadata for Hedera? Handling all of that. Now, I don't think this is actually necessary when you're using the if you're using an already deployed DVN or executor. So to my understanding, I don't think that would be required because the operators, the executors, DVNs that layer 0 set up already have that configuration in place, but because we're just deploying it from scratch, we need to sort of give it that understanding.
That's right, but in the wiring, you're also setting up the routing as well, so you can know which chains are talking to each other. But as far as mocking out the DVN and the executor, that's the step that's he just said that wouldn't need to be taken care of. You can pick your own DVN and you can set your own executor, so you can wire it up. But what happens typically under the hood is the layer 0, the layer 0 team has a DVN network they already have, and they have an executor that they already have, and it defaults to that.
Okay, shall we? Let's deploy the OFTs now, and then as well as deploying the OFTs, I'm going to show you how you can actually verify the smart contracts too. So I'll just copy and paste this bit over here. We'll deploy the OFT on, of course, on Hedera and on base in those networks. Just sort of click through enter, and you actually need to do it once. This network doesn't actually do anything. That network flag doesn't actually do anything. So you can just actually paste in this particular section. You just paste in this section here. But you can see that we've now deployed these fungible tokens, which are compliant with the Omni-Chain Fungible Token Standard, the OFT, on both Hedera and on base. And what we can do on Hedera, if we go to the base Sepolia base scan already has quite a strong support for ERC20s, because obviously the Ethereum-based networks, the only way you can create a token is ERC20s. Is pretty much the only fungible token that you can do. So they've got, out of the box you can see these tokens. On Hedera, because we've got different types of tokens, we have a native token, which is more efficient, but isn't a smart contract in and of itself. What you'd have to do on Hedera is go to that contract address, go over to Hashscan, you can sort of search it in, you can find the contract over here, and what you want to do is you want to verify it. So I've already have verified it. I can deploy it again. If I delete our FT deployment on Hedera, I can deploy it again, deploy a fresh one, and go through the smart contract verification process. So we see it's now deployed a new one. So we've got this new Hedera testnet ERC20 token, which complies with the OFT standard. And verifying is very straightforward. You can do it manually via the user interface. This is how we do it today. But you can also use Sourcify to have it inside of your hard hat configuration or inside of your Foundry configuration. And all you need to do is make sure you're inside of the repository, you've sort of compiled your contracts. Inside of this artifacts folder, there's another folder called build info, and that contains the information of the compiled contracts. You just basically need to upload that file. In there, there'll be some information about the contracts that you've deployed, and via the user interface, it will verify it, and it will be able to realize, okay, this metadata, this build information maps on to the contract that I've just deployed. And once you do that, we'll see that we get an enriched view of the smart contract information. Because we've compiled quite a lot of contracts, which we're not necessarily using today, it will take a bit longer than usual. But you can see that's because we've got all of these other contracts over here. Bulk Composer, Share OFT, which we're not using right now. If we do have more time, then we can definitely go on to continue with the demo. How's it going for those following along? Michael, do you want to see if maybe... There we go. Verify. So it's got the name of the contract. We'll now actually be able to see the ABI, so all of the functions and sort of methods associated with the contract, and the source code for it too. And when we start triggering some events, we're able to see a what's the word? Not decrypted, but decoded. We'll be able to see the actual names of the events and the arguments that are being passed in. So let's just take a quick recap as to sort of where we've got to now. So we have deployed we've compiled with the smart contracts, we've deployed the local DVN and executors. We have deployed the OFTs both on Hedera and on base Sepolia. We'll configure the OFT simple workers now. And this is doing exactly what Michael mentioned earlier. This is basically telling the contracts that we've deployed which networks you'll be communicating to and from. And then we can get to the fun part, which is actually transferring those tokens from base over to Hedera. And we'll go into what all of these flags are, this source EID, the destination EID or the endpoint ID, and the other bits and bobs. But in the meantime, while we're setting up the Layer 0 asset configuration, what we can do is we can take a look actually at the contracts we've deployed. So we've got a contract, OFT contract on base, which we can see over here. Let's copy that address. We'll be able to see on base that the contract that we have over here has 99,999 total supply. And that's because I did a test earlier on. The Hedera contract which we just deployed, we can see actually the total supply or the balance of my address. So we can have a look at the address which we're using, which is this address over here. And we can call the balance of function to check how much balance does my wallet have. And as you can see, it's got, this is 100,000 times by 10 to the power of 18. With the EVM, it can't handle decimals. So what you do is you sort of shift it up a bit and you specify how many decimals the token has. In this case, the token has 18 decimals. So sort of 18 of these zeros would be representing an actual decimal essentially. And we only have 10,000 or 100,000 in there. Okay, so we've wired it up. We should now be good to run the transfer part of the demo, which is going to be going through that flow which Michael described earlier, sending a message on base, burning the token so that we don't have this sort of inflated supply, burning the token on the source chain, creating the packet which says, okay, I've just burnt it over here, let's mint it on this Hedera chain, creating the packet, sending it to the post office, the executor, the endpoint, stamping it, doing all of the checks and balances, and then putting that over to Hedera to then sort of validate it and then mint the tokens and release it to the actual end user. So if we go for the Pippin hard hat, there was the OFT send, we can see that we've passed in this source endpoint ID, we've passed in a destination endpoint ID. What this is the ID which Layer 0 has for the relevant chains. So base has an ID of 40245. Hedera has an ID of 40285. We're going to be transferring one of those tokens, and we'll just be transferring it to the same address. But of course here, this one is actually 1 times by 10 to the power of 18, because we're including the decimals. So the source code will handle that automatically. But if I click enter here, I'm hoping it works. I've just realised it might not because I deployed a new contract on Hedera and I didn't deploy a new one on base, but maybe the wiring would have sorted it out. So we can see it's going through it. The DVN's verifying the message. So the first step was discovering all of the mappings. This is what our configuration did. It's configured, okay, we can actually go from Hedera to Sepolia and vice versa. It is sending the transaction, so it sent 1 token. verifying it, and then actually it's executing it. So cool, it's done it successfully. So in theory, if we now go back to our block explorer, if I refresh this, we can see that's 99998, whereas before there was 99,999. And if we go over to our balance of and our current account, we should see, there we go, we've transferred 1. So this is the 18 zeros, and we now have 10,001 on Hedera. So we've successfully gone from base over to Hedera pretty quickly, very securely, and of course the use cases here is more so than just transferring from A to B, right? What you could do, and actually what I'd recommend if you sort of followed along clearly over here, you could start maybe doing some more complex DeFi flows. So for example, you could set up a vault on Hedera, which maybe is, you can think of it as like an ETF of HTS tokens. And you can set up this bridge such that you pay with Ethereum, ETH on Ethereum, transfer that over via layer 0 to Hedera, then it becomes wrapped ETH. And then you can use that wrapped ETH to buy this, invest in this vault. And that vault might then, on the back end, go to SaucerSwap and buy a basket of different HTS tokens. So you've basically given access to users on Ethereum using ETH. You've given them access to exposure to some HTS tokens on Hedera. And that's just really scratching the surface. But yeah, if you want to sort of, I recommend doing this in your own time. We've got 2 more chapters as part of this demo where you can actually set up a vault, the ERC 4262, I believe it is. ERC 4626. This is the Ethereum standard for doing vaults. You can deploy a vault, you can integrate vaults with layer 0, do cross-chain bridging with layer 0, and then you can sort of extend it even more, so maybe that vault calls some complex logic to provide something like an ETF. How's everyone getting along with the demo? How's it going? So you don't send, you send the tokens which you've created on Sepolia. So what you've done. So did you deploy the OFT over here? Did you do this step? Okay. On Sepolia. Okay. Give me, let's get your address. I can transfer you some. What's the Hedera testnet ID? Do you want to share? I can send over some base Sepolia. Is good? Okay, cool. So then probably go to the faucet and just paste in your EVM address for Sepolia, and then get some HBAR on that, and then boom. Essentially that first it would be deploying the OFT, which again, if we look at the OFT contract, it just looks like this, right? It looks very similar to a fungible token. We're specifying that, okay, we're going to mint 10,000 with 18 decimals on both chains. So both chains will start off with 10,000 tokens. Both chains will start with 10,000 tokens on either side. And because we can't inflate the supply over here, there's no mint function. We can't mint more. That's going to be the total supply forever. There's only ever going to be 20,000 tokens in circulation. Of course, once we start transferring tokens over from Ethereum to Base, or from Base to Hedera and vice versa, those tokens might be distributed across the 2 chains differently. Sometimes it might be 5,000 on Base and 15,000 on Hedera. And that's because of that burning mechanism. Whenever we want to transfer it, we don't lock it and mint new supply. We burn it and mint new supply. Should we go over to the wrap up while we're doing stuff in the key takeaways? Yeah. Let's go to the key takeaways, and then we'll check back in. Is things going a bit more smoothly now? Let's get this done. For us, I want to have one person doing it. This is a success for me. How about, do you want to come up on stage and plug it in, and then we can do debugging live? I think that would be really valuable to those tuning in online. Because often, problems will be reproducible. So we've got, do we have a USB-C to HDMI adapter by any chance? Hashgraph Hustlers Live, that's it. It's an hour, we've got an hour here, don't we? We've got 20 more minutes? Let's do it. Let's debug live. This is the real helpful part. Just, this is not a mainnet private key, yeah? This is only on testnet. Good. Okay, perfect. Yeah. Right, let's go. Let's take it step by step. We'll go right from the top. So this private key is now lost. So I've lost thousands of private keys. Okay, so are we able to see this screen on the? Yeah, it looks like we're hooked up correctly. That's good. So, where have you got up to as of now? Let's just go. Yeah. Okay. So where did that private key? Where did you get it from? From the portal. Okay. So yeah. So if we
what would be better is to just use your private key from base. And then fund a Hedera wallet at that same address.
Yeah. Well, did you have set up base with MetaMask?
Yeah, I have base.
Okay, let's get the base Sepolia account up. That's the one, yeah? Awesome, okay, you've got home, so we've got testnet. Okay, so let's just go over here, copy that, and then just transfer over some base over here. Let's do max, and just keep a bit for gas. Is this base or is this Ethereum?
I might not be able to.
I think this is actually Ethereum.
Oh, that's why.
Okay. Or what we could do, we could add Ethereum as a network. Yeah. Oh, we could add base as a network. Yeah. But then we'll get some new stuff. So if we do
Ethereum on base.
Do you know what we can see testnet mode? listings. Networks, base, Sepolia, let's look up base Sepolia, so it's enabled, so I guess if we do you know what it is? Yeah, so what did you use for the faucet? Did you use alchemy or something like that? Yeah? Okay, do you mind going to the, let's go to Agri and then we'll top up with base Ethereum, and because you've already got an account, it should be, let's unplug this for 10 minutes.
Yeah.
Hopefully you don't get 2FA. Amazing. Okay, let's plug back in. Okay, here we go. So, we've also got. So if we go to the faucet, I think there's a sorry, it's this faucet. Faucet, how can you basically boom. Let's request our, so we'll do it in this account. This. Through. Hopefully I'm sure if you sign in then they give like okay, do you know what? I will transfer you. I will transfer it to you. That would be quicker. So this is the same account. So this is, let's do this. I'm going to transfer it to you because I want to have, this is very important. It's getting people to do it end to end is what it's about. So let me transfer you that. We've got 4337 557. Basically, I've got 0.25. Okay, let's send over. I'm feeling generous. You're going to get all of my base. All of my base. You're going to get 0.25 Ethereum on basically.
You might need some ingredients.
Nah, it's cheap. It's not cheap. Nice. Oh, I just said H bar.
Oh.
Okay. So basically. Oh no, I didn't. No, that was just a bar. Okay. So let's now go. Let's check this on base Sepolia scan first. So if we go to base Sepolia scan. Test, there we go. If I paste in your address, you should have 0.25 ETH. And you shouldn't have that no funds error. Yeah, let's go, let's go. Hustlers. Okay, back to cursor. So you've done that, and then did you deploy these yet? I don't think so.
I think deploy them now.
Okay, boom. Okay, so we'll do a, let's go, npm,
Yes.
run. Yeah, that's right, Boom. Yeah, that's a really good point. If you don't have PNPM, it's not the end of the world. You can just do npx. So let's do that.
Yes.
go. We're in the green. Let's do npx hard hat LZ deploy over here. Same stuff. So yeah, it's already deployed. What hard hat does quite well actually is if you've already deployed it on testnet, it doesn't redeploy, it just uses the same one. Let's deploy the OFTs. This will deploy both on base and Hedera. And we'll do your wiring up. This will be first. Yeah. What's really cool actually is actually, yeah, you can do, well, on mainnet we've got the official wrap teeth as well. So that's like, okay. Yeah, nice, that'd be cool. Let's go. So yeah, so what you can do as well is because the Hedera Foundation did a really great job of improving the sort of liquidity for Ethereum on Hedera and also Bitcoin on Hedera. So now our ecosystems have the official wrap teeth, the official wrap Bitcoin, which we can start integrating into our DeFi flows. But it's good. And then we can do the final step, which would be transferring. So while this is happening, let's just verify our contracts on Hedera. So we can take a look at the deployments. Hedera testnet, IFT, this gives us the address. We can then go over to HashScan, which is over here, and we can deploy that.
We don't really need to do verify stuff, right?
Well, it does help actually to see, because then we can query the balance on the HBAR side. I'll do it just in case you've got any private files. Yeah, just in case you've got any files that would be good to see. Do you mind finding the folder for which we were just working in now? That's the one, yeah. Here we go. Let's plug it back in just so we can see. So here we've got in the where is it? It's, is it artifact? Yeah, artifacts, build info. This is the one that we want to give. That's the one. So this will sort of upload it. Probably by now. I've deployed over here, so we can then do the final step. The actual transferring it from base over to Hedera. The to address is to yourself, so that's this EVM address. Boom. I'm going to specify to use the simple workers. And let's see, okay.
We're not using HTS tokens. It's pure ERC for this example.
Yeah. So that just so that I don't think the question was picked up on the mic. Really great question. The question was, does Hedera automatically associate the token before transferring over? And obviously the reason why you asked that is because you're very familiar with the native HTS system, where with the HTS, the native Hedera tokens, it worked. We can check it out after this, but I do want to answer this really great question. So with the native Hedera token service, we have this concept called association, which basically means if you want to transfer a token to another person, unless they've associated to that token, they won't be able to receive it, unless they have auto associations or whatever. But generally speaking, that receiver needs to have said, yeah, I'm happy to take this token. And the reason for that is it's actually lots to do with compliance. I mean, imagine, let's say you're a business and you've suddenly been transferred a token to your wallet, which is worth 100 grand. Obviously it wouldn't happen, but it might, right? Suddenly your accountant's like, hang on, we've just been sent this and we need to pay taxes on that. By saying no, only if I let you receive tokens, only if I associate to it when I receive it, it eliminates all of that overhead. But the reason why it's not particularly important within this context is because we've done a OFT using the ERC20 standard. So ERC20 is the token standard on Ethereum, which is a smart contract, and there's no concept of association over there. Obviously, with Hedera being EVM compatible, you can use those standards really well. It's super easy to do. However, if you are interested in using the hybrid approach, where you use OFTs and the EVM and the native tokens, what you want to do is you want to have a look at the Hedera docs. Because we've got what's called the HTS connector.
It's a connector contract. I can talk about it.
Go.
It's essentially the OFT standard contract, except it just calls on the HTS libraries for mint and red.
This is what it is.
But otherwise, it's pretty much exactly the same.
So you can see it's like sort of pretty much the same. We've got this.
It adds in associate and the constructor when you deploy it.
So I think we can see the source code for it. Let's take a look at OFT adapter. HTS connector contract. So we can see here, for example, this is the source code for it. Example HTS. You can see here that it's using the HTS connector, which comes from over here. And what this is using the HTS precompilers, which if you're a Hedera native builder, you'll be very familiar with. But this is broadly doing the same thing. It's sort of creating a fungible token, which is Hedera's native version of an ERC20. And then it's also, when it comes to debiting and crediting, so it implements the same interfaces, but we're using the Hedera token service, burn and transfer. So it's sort of, this is if you want to use that hybrid approach, we'd recommend using this. But we've not done it in this example, we kept it a bit simpler. This would need things like association for sure. So now, if we take a look at our contract that we deployed on base, which we transferred it from, if we go over to base Apolia, we paste in that contract address, and we click enter, and we see the OFT tracker. We see that, yeah, that started off at 100,000. Now we have 99999, and equally on the Hedera side, if we go to our, if we do the balance of, let's refresh there, should now have the ABI, yeah. So if we go to the balance of this address, which started with 10,000 and then received 1, we should see that, boom, got that 1 over here. Let's go, my man. You did it.
Yeah, good job.
And that's it. That's how you bridge from Ethereum base to Hedera.
You want to do key takeaways?
Let's do key takeaways really quickly.
All right. Just some key takeaways. So that was the demo. To get into key takeaways, and we'll wrap it up, and then we're done. So we started out by describing blockchains like islands and how bridges let them talk to each other. And then I described at a high level the technical flow of how layer 0 passes a message from one chain to Hedera, in this case base. And Jake demoed it and even debugged and helped this guy in the audience to transfer a token.
Gave him 0.25 base ETH in the process.
And he gave him
send that back, mate.
Yeah. From base to Hedera.
It was testing.
So that is our presentation. We hope you guys enjoyed it. And if you have any more questions about at a deeper level how the protocol works, come talk to me or Jake, and we'll get you cleared up and send you on your merry way. Thanks.
Thanks, everyone.
All right, everyone, what a great workshop by Jake and Michael on cross-chain interoperability. Now for our last workshop and last hands-on session for the day, we're gonna get into a workshop that covers zero knowledge proofs, confidential execution, and privacy. And so for this workshop, I wanna welcome Nadine Lopfe and Keith Cole to the stage.
Thank you. Welcome. Hello, Dev Day. We are the last workshop of the day, but of course, the last is always the best. I would also make a call out that after this presentation, we will be having closing remarks from Richard Bear, and I believe we're also having the winner of the scavenger hunt. So please don't take off after this presentation. Stick around for the closing remarks, and hopefully one of you will be a winner. So the last workshop we have for today is all about confidentiality by design. Basically talking about privacy on L1. Maybe to kind of intro this, I think that for many of us who've worked on blockchain, one of the key aspects of blockchain is that it is public, it's trustless, it's auditable, everything, you can see all the different transactions around accounts. And obviously, this new dynamic of privacy is in many ways very counter to that. But, it certainly is a growing need we see, and we see lots of L1s and functionality around blockchains coming up around privacy, because I think we've all recognized that this is a strong and growing need for users of the blockchain. So just a quick agenda. We'll be first talking about what do we mean by privacy. This presentation will be focusing specifically on enterprise privacy, and I'll talk about that. Some different overview of privacy approaches, and then Nadine will be taking over with the hands-on approach for this, with some hands-on workshop of how you can bring privacy to Hedera for your own enterprise applications. So I'd like to start by, I think when we say privacy, many people think of different things. And in fact, if you look at different technologies on blockchains, many of them take different technical approaches about how they approach privacy. So I think it's always good to first ground is what do we mean by privacy? Now, the first thing we can talk about is, I actually come from the decentralized identity space, is identity privacy. I don't want anyone to know that an account belongs to me. My account on Hedera belongs to Keith Cole. I don't want an association between my account ID or my public key and me as a person. So obviously that's one thing when people think of privacy, that's what they're talking about. Another one, especially as we look towards maybe enterprises or users, is transaction privacy. They don't want to know, I send money to Nadine, they don't want people to know that either my account or her account, they don't want anyone seeing what account did what with what, or what account interacted with a smart contract. They want that all to be hidden. Some other ones, they just maybe look at more amount or value privacy. They're okay with knowing that my account transaction with Nadine's account, but they don't want anyone to know how much or what token. They want all that to be blurred about what was the actual transaction between us. And then finally, I think a growing area is state and data privacy. Often this means not wanting people to know the state of your smart contract, so maybe you could kind of re-engineer about what was happening to the smart contract. But on Hedera, it could mean things you don't want people to see, we have the Hedera consensus service, you don't want people to see whatever you're doing on Hedera consensus service, or there's many different elements to that. You want to blur whatever state you have on the blockchain. So, there's going to be many more we can add to this, but I think this is a kind of a broad overview of what do we mean when we say privacy. Also, the key thing is, a lot of people, when they talk about privacy, they're talking about user privacy. I don't want the government knowing what I am doing on the blockchain or other people. It's what I do on the blockchain is my business. So I think that's certainly one component. Now, we're not going to be covering that much in this presentation today, but obviously that's very important for a lot of people. We're going to be focusing more on enterprise privacy, and I think that there are some very clear, distinct needs around enterprises for privacy. And this is really about that I, as a business, want to use the blockchain, I want all the inherent benefits of the blockchain, but yet I don't want all my competitors knowing everything I am transacting on the blockchain, whether you're doing some sort of a supply management or you're doing stable coins. I want to hide this from public view so I can interact on the blockchain, but yet not let the world know what exactly I'm doing. So with that focus on enterprise privacy, then we can start breaking it down. Even under enterprise privacy, there's many different characteristics. I think one that many people forget about is that where I think enterprise privacy differs a little bit from personal privacy is that personal privacy, I transaction with Nadine, that's it. I don't want anyone to ever know about it. It's done. I think enterprises are a little bit different in that, especially if you're talking about enterprises doing legit business, they do have this auditability component. Yes, I as a business, my business wants to interact with Nadine's business, but if the government or other parties ever come down the line, I do need like an auditability layer so they can say, yes, like I did send X to Nadine, like that is provable in some later audit situations. And that's a very, I think, core and distinct requirement for enterprises that's also kind of difficult to manage as well. Of course, you have the confidentiality and data protection. I don't want what other, I don't want my competitors knowing who I'm transacting with and what I am transacting. And I also don't want my competitors to know the state of my account, for lack of a better word. Often, like when you're talking about privacy on enterprise, often this is like kind of a consortium situation. So, they want to know who it is I'm interacting with. They want to know the identity of the different parties that they're interacting with. They like a KYB layer. They don't want to be interacting with just anonymous parties because again, they have a responsibility to know who I'm interacting with. Is that person approved? So you have that whole kind of identity layer with enterprise. Governance and policy. So often, again, these are constructs where maybe you want that governance. So again, back to the identity side, I want to be able to say like, I have a governance layer saying like, who are the parties allowed to participate in this private network, and what is the governance and rules around that. And also tying to that is, if I'm transacting with Nadine and then there's a dispute about what happened or did I really send her 100 tokens and maybe she says I sent her 95 tokens, well then you kind of tying back into the auditability, you need mechanisms in place where you could, if I sue Nadine, there's a way to resolve disputes. Again, that requires that in the privacy component that there is this kind of auditability layer so we can, bring this up in court or resolve a dispute amongst ourselves. And finally, when we're talking about an enterprise system, they want resilience, they want scalability. So, it has to be a robust architecture, especially since, one of the things about privacy, especially if we're going to talk about ZKPs or ZK snarks, this is ever evolving tech. I mean, this tech is rapidly evolving. So I want to make sure I have an architecture in place that's kind of, well, I don't know about future-proof, but certainly it's not going to it's scalable and can move forward without causing too much disruption if the technology underneath the hood changes. So I'll just talk a little bit now about different kind of approaches that the market has taken. Now some of these are more on the user side, some of these on the enterprise side, and you could probably nitpick about, especially with some of my examples, maybe they don't fit cleanly into these buckets, but I've tried to do the best job I can. So if you take different approaches for privacy, you can start with obfuscation mixing. I think the famous example of that is Tornado Mixer. Basically, like you dump a bunch of transactions into a pot, you stir it around, you try to break the unlinkability between transactions, and then you get an output at some later stage, and hopefully nobody can figure out like what A gave to B. I mean, that's the old school way of doing it. It's more statistical than like having cryptographic certainty, but this was certainly an older way. I would say more a legacy way of doing it. Of course, the new way to do it that's all really hot right now is ZK snarks, cryptographic privacy, where you can basically using data sets, you can prove something about a transaction without actually revealing the data values themselves. And this is obviously like very much in vogue right now, and it's probably the leading edge of tech when people are looking to implement privacy solutions is around using some form of zero knowledge proof solution. And we have our expert kind of sitting here, Rohit, to keep us honest, and he is our in-house expert on all the ZK snark technologies. You have confidential transactions like Liquid Network or Grin, where really their main focus is not so much about maybe shielding the sender or receiver, they're more just about shielding the transaction values. So it's more like a limited utility for privacy. Something you see really new right now, especially like the Oasis network, is around this trusted execution environment where I can deploy an encrypted smart contract on any network, but then you use this kind of trusted execution layer to actually do the operations of the smart contract. So there's quite a few different examples of that out there right now, but it does require like dedicated hardware or trusted execution environment to execute specifically smart contracts or in the EVM layer. Again, maybe more old school, you have like the permission layers. I think the most famous one of this would be like Corda. Corda always talked about transaction privacy, and this was really because they had a permission network where they didn't allow people to have visibility on what was happening. Fabric has also kind of gone at that as well, and Quorum. These are like permission networks where the privacy comes from that they only allow some people to see the actual network itself. And then finally, I think probably like, if you look at real life solutions, especially the leading ones, they combine different elements of what I just talked about. They combine ZKP with maybe permission, and you see lots of examples of this. Most recent one would be Jolt ZK EVM, where they've taken more of a hybrid approach for how they approach their privacy solution. And the other one we'll be talking about in the need we'll be presenting is Nightfall, which is again combines different elements off-chain and on-chain for a privacy solution. So what does privacy look like on Hedera? Well, I think it's, we're still looking at the market and the best way to bring privacy for our enterprise users, but certainly something that users can do today. We have HashSphere, and we have a lot of reps here, so that should be the approach that you could have a private network with your partners interacting with it. That's one way to achieve privacy, and that's a very exciting product that we are developing. There's lots of different smart contract solutions out there where you can bring privacy to Hedera, and that's the demo we'll soon be giving, is how you can use Nightfall as one example of how you can bring privacy, very quickly, have a privacy solution on Hedera. And then there's also hybrid, where you can combine something like spheres plus a smart contract solution for a really custom tailored solution, where you can have a private network with lots of different players, but even within that private network, you can shield interactions from one player to another from other players on that private network. So with that, I'm going to pass it over to Nadine to talk more about what one of these smart contract implementations on Hedera could look like, so you can have privacy for your enterprise.
Awesome. Thanks, Keith. Hi. I'm going to talk to you about Nightfall, and I want to keep this super relaxed because, let's be honest, ZKP can be a bit scary. It's very mathematical, sometimes people's eyes glass over, so we hope to make this quite interactive and easy to follow. So why Nightfall? Nightfall, as Keith already said, is a really good example of an enterprise solution actually for ZKP. It has actually been developed by Ernst & Young, and Ernst & Young have done this actually on Polygon. So Nightfall enables secure and private transfers, and it does this with ERC20, so fungible tokens, ERC721, so your non-fungible tokens, as well as ERC1155s, so both combined kind of. And it does it with zero knowledge proof, and then added scalability through optimistic rollups. Now, with this solution of Nightfall, you can hide who is sending and receiving tokens, how much is being transferred, and also what tokens are being moved exactly. And these are really important things for enterprise clients. Now, what's also really important for enterprises is that while the actual transaction should be confidential, we don't want it to be fully anonymous. And this is where the X509 certificates are coming in. So you need to do some authorization with that. So basically, it's known what identity is on the network, same as, for example, Corda, on what Keith touched on. Now, you can use your own certificate authority, so it's not prescriptive of which one you should use. So you're kind of free to choose. So benefits, as we already said, private transfers, which everyone wants, and then up to 90% lower gas fees. Now, it's important to know that, of course, as this has been done with Polygon, and this is 90% lower gas fees to classic EVM tokens. On Hedera, this would have been less anyways. And then also when it comes to the security, we keep the same ABFD security that Hedera already provides. So it's not making it more secure, it's not making it less secure. Perfect use case. So let's briefly talk about the main elements of this solution. Of course, we have layer 1, which is Hedera. And then here as a layer 2, we have the Nightfall layer, which again is our encrypted private layer on top. So in a nutshell, how the solution is working is that we move our tokens from L1, so from Hedera, into L2, so kind of in a private shielded pool. And then everything that is happening on L2 is going to be fully private. So I can transfer with Keith, I can transfer with Alice, Bob, whoever, and that will not be visible. However, when it becomes visible again to the L1 ledger is when I withdraw. So as soon as I move my tokens back from L1 to L2, I will be going public. I hope that this concept makes sense. Now, how this is exactly working is that we have encrypted commitments. Now, these encrypted commitments, just to go back to, for example, the chord analogy that we had before, where you have like states that you can mark as historic, it's taking your transaction and brings them together in a basket, and it says as soon as they are spent, it nullifies them and shows that this has been spent and cannot be used again. Same as kind of Bitcoin's UTXO model, if that makes more sense. Also, what we have is roll-up batches. So we will have this group of commitments with the transactions, and then we roll them up in these batches to then submit them. So this is the solution in a very high overview. Next, we can look into who's actually the key player, who is on the network, and who is part of it. One part is, of course, the user. The user wants to make a private transfer. Then what we also have are the proposers. So the proposers batch the transactions into blocks, and then we do have challengers. So proposers batch the transactions, and they do that in a kind of optimistic way. So what they're saying is, until no one challenges me that something is wrong with this block or this transaction, we are going to commit that actually to the ledger. That's the reason why challenges come in. They will verify that really everything's okay, and if they flag a commitment or a transaction to the proposer as being wrong, the proposer loses their stake. So it actually makes the whole solution more secure because it's incentivized to do the proposers to do their job correctly. And then last but not least, we have liquidity providers. Now, in this solution, Nightfall, how it is working is that if you want to withdraw, you have to wait 7 days until you actually can get your money back from the smart contract. Why is that? Because of the challenge period. So that challenging period where the challengers can come in and actually say, hey, something's going wrong. Not everyone wants to wait for 7 days. Depends what you want to have to do with the money, but there is where the liquidity providers step in. The liquidity providers will check if everything's okay. If so, they already pre-fund you the money and then later take your stake. I hope, so far so simple, I hope everyone's following. Everything's better though with the graphic. So this is how the solution kind of looks like on a high level. We do have our decentralized app. Now we have a client, so the user, me, later when I use the app, I'm going to interact with the client. And I'm going to do, let's say, deposit or transact, anything. That is going to be pushed from the client to the optimist. So the client is actually assembling the SecKey keys, mostly done by the worker who does the heavy lifting. And then it sends it to the optimist. The optimist is bringing all the transactions together and brings it into a block. And then, when that's ready to be committed, the optimist moves it to the proposer, who then sends it to L1, which here is Hedera. And now I need to switch my screens, if I can do that. How am I doing it? Perfect, thank you. So, we are now going to go semi-hands-on. Why semi-hands-on? I only have 30 more minutes, and unfortunately deploying smart contracts, start getting some Docker images and doing all of that shebang will take a bit longer than 30 minutes. So we are gonna not do it exactly from scratch, but I talk you through and I show you the solution. And if you can start already deploying your contracts, by the time I'm finished talking, you should be ready to go. You can find me later on the studio station, and then we can go through it together if you have any questions. But for now, I want to say hello to this beautiful repository, which is the Nightfall version 3 repo on Hedera. Now, this repository has been created, unfortunately not by me, I wish it was me, but it was Giuseppe Bertone, my colleague. He has taken the original solution, and what he has done is he adapted it for Hedera. As of course Hedera is EVM, we didn't have to do so many changes, but we still had to kind of fork it, find the right branch and do it. Now first I realized we missed a slide. Can we go back to the other presentation quickly? Or I can do it here actually, sorry. This is important. If you want to follow along, you can scan this QR code, or you can just go to github.com internetofpeers/nightfall_3 workshop. And then we can follow along. Sorry. But yeah, now let's dive in how to do a very easy deployment of the Nightfall instance, and then do a deposit, transfer, and withdrawal flow, and we see how this is working. So going back to this repository. Again, thanks Giuseppe for doing this tutorial. So the README is actually really good. If you follow along, you should be able to just copy and paste the commands and to go over there. What you need is $10 worth of HBAR, so you need the Hedera account. And can be ECDSA keys, ED25519, actually doesn't matter, just sign up on the Hedera portal if you haven't yet. You will also need Docker Compose and Nodes. I usually use NVM as a version manager because it's just the easiest to switch. And then for the browser extension, you either can use MetaMask, or I would highly recommend you to use RabbitWallet. Now RabbitWallet just has a better UI, and it's also easier to deal with nonces. So if you want to download that now, it's a brilliant time to do so. You just have to, of course, configure it to point to the Hedera testnet. So chain ID 296, symbol, of course, is HBAR, RPC URL 7546, the usual shebang, and you can also put the block node explorer, which of course is hashscan. Now, for other suggestions, I usually use Visual Studio Code, also for this demo, just for the overview. You also will need to have jQuery installed if you don't already have. And yeah, that's pretty much it. And we can go into the environment variable setup. So if you see here, you will need your native account ID, you will need your EVM account ID. Now, how I usually like to do the same as Giuseppe is to just put it into my shell file, so my here it's set as HRC. Why so? You can just use it across multiple repositories, so you do not have to constantly import it as a new file. However, of course, you can do it just as an end file on project base. Then if you go down, you see here the repositories and the command to actually git clone them. So you have two repositories here. One is Nightfall version 3, and the other one is the workshop. What you have to do is you have to go to the Hedera branch. That's very important because Nightfall version 3 actually is discontinued in a way. So there's now Nightfall version 4, which is a bit less stable. And we went from the Aquafix Eve Sepolia branch, which is important to go for because it has a lot of fixes that the main branch doesn't have included. as soon as you have downloaded that repository, now comes the fun part that will take at least 5 minutes, with this internet connection probably 10. And that is, we have to download our Docker images. So as you can see here, we have a client, a deployer, an optimist, the proposer, and it's going just to pull the newest version of the images, and after that we can move on to the contract deployment. And you see I'm kind of rushing through the setup steps because really no one wants to see 10 minutes of code in a terminal being deployed. But what I want to point out is these really cool setup scripts that we have here. So if you actually switch to your Nightfall directory, there's a Nightfall _3 workshop directory, which has helper scripts that help you show what your current HBAR balance is without having to log into your wallet, or it also helps you to create a new account. Because for this workshop, we will need 2 accounts. So if you just so far have one, you can just cd into the Nightfall -3 workshop directory, run create account, and what will happen is it gives you a full new EVM address, private key, everything that you need to know. Next, you can just make note of that account and transfer some HBAR into that account, because for the workshop, as we remember, we need $10 in both accounts. If I run the script here, I can see transaction successful. So that means my both accounts now have 100 HBAR, and I can move on. Next step, favorite one ever, JSON RPC relays. We already heard a lot about it today. Why run your own JSON RPC relay? Mostly because of rate limits. If you use Hashio or anything else, you can run into rate limits, and also for logging and debugging. If you use your own JSON RPC relay, you can just click into it, you can see your logs. Your life is so much easier. What you can do, you can check that your environment variables are properly set, so you can cd into NAT13 workshop directory. Again, there's a script for that, and you see now everything's properly set. We're ready to go. And then I can run my local JSON RPC relay if I have not already done so. All of this is of course also in the README, so it should be pretty easy to follow and self-explanatory. Next step is deploy the contracts, and here again, if you need to check that you have everything environment variable wise, you can do that. And now in the configurations, we have all already done this for this workshop. So if you clone the repository and follow along, you do not have to worry about configuring your environment variable, deployment environment variables, because they are already done by us. Of course, if you would want to have it as a productionized solution, you would want to customize these. That's the reason why we flag the files to look into. And then the deployment can happen. If you run the deployer, it should take 10 minutes, maybe 20 here, who knows. And after that, if you go to Docker and volumes, you should see this artifacts and build and proving files directory. Now, you can see here we have the challenges, you have the proposers, the SHE contract, which is most important, and then of course the X509 certificates that are in there. Proving file-wise, we have here the powers of Tau. So these are the Romani files. They are coming straight from the Polygon or the Google API store. If you don't trust them, you can create your own ones. It's going to take some time, but I would heavily recommend just going with the ones that we have in here. And then, next step, very important. In Hedera, of course, we don't really have the concept of a block. So what we want to do here is we want to set the state genesis block, and we want to set it to the current block because otherwise we're going to go all the way back, and the mirror node doesn't really do anything here that's longer than 7 days. So this is this command here. You can copy it, you can paste it in your terminal, and what you can see here now is it says the current block number, and it will put it for you in your variables file. Again, if you want to look what's in there, you can. They're all in the bin directory. It's all already been pre-configured by us, but you can do play around with this. And then when everything is deployed and done, we can remove the orphans, and we can actually start Nightfall, and this is now where it gets fun. So what we're going to do now is we're going to go into the right directory. We have to make sure that we are in Nightfall 3, not the workshop. We want to be in the proper solution. And then we set the version to node version to 18, and we're going to start our Docker containers. And as we can see here, a lot of logs. A lot of logs that are hard to decipher because there's a heartbeat, and I would really recommend to toggle it with just this post request. It's going to make everything a bit more readable. But you know what makes stuff even more readable? Not having it just in one terminal. So the best that we can actually do is open a couple of new terminal ones, and we can do this with these two commands here to only get the logs for the client and the logs for the optimist, which are going to be the most important ones for the demo application that we're going to run in a sec. Now you can all see my very beautiful desktop wallpaper. And me shuffling around some terminals. I hope everyone can kind of see that. So it's just important that you kind of can see, spot what's happening there at the moment. In the client, not so much. Of course, in the Optimist, also not. But as soon we are up in the UI, we will see how the transaction moves from client to Optimist and then later to Proposer. Awesome. Next step and last step, start the Proposer, and then we can finally start our demo UI. I'm just doing this in my VS Code. There we go. Of course, I could also do this just in my Docker desktop. I would just constantly have to switch the different logs. So if you want to do it and just follow along, I would highly recommend to do it this way as a setup. And we see here the Proposer has been registered in the Optimist. So we get a 200 return from the register endpoint. So our setup is fine and ready to go. And we can finally start a demo UI. Why demo UI? We all love scripts, but it's just so much easier to follow along and to see some concepts, especially when it comes to users in, or wallet users in L1 and wallet users in L2. So to do this, you can cd into the Nightfall 3 directory and then into demo-ui. And then we're gonna just switching here profiles because separation of concerns. There we go. And then this is our beautiful demo UI. This is very simple. You can now see my Rebby wallet here on the top, which is the blue bunny, which we're going to look into. And then what we can see here is the wrapped HBAR address. So what we have to deposit actually is wrapped HBAR, not normal HBAR. Now, if you look, I have already set up 2 accounts. One is Dave and one is Carl. And Dave as well as Carl have already wrapped HBars. If you don't know how to get wrapped HBar, it's actually super simple. You can just copy that address that you see here on the screen, and you can send the amount of HBars that you want to have as wrapped HBars to the contract, and the contract is going to return wrapped HBars to you. That's this address I'm referring to. So, just to show you, I can do 100 HBar. I've just saved here the contract address. I click send. I sign this transaction, of course. And now I see I have 100 wrapped HBar more. So more than ready to go. So Carl and Dave are our 2 personas on L1. So they have our private Hedera keys, and we now using them to follow along. Oops. Let's go. Now, what I can do, sorry, went a bit too quickly. Great, so what I can do now is I can select Carl and I can create a user on L2. Now I'm gonna, just for the sake of making this concept a bit more clear, I'm gonna not name this user Carl, I'm gonna name this user Alice. And this user is gonna get a mnemonic. You can use your own, or you can just check one here in the UI. And then I click add user, and I see that Alice is now coming up on the right side of my screen. And you can see that Alice has also this green kind of circle dot, which means that Alice is currently active. I see Alice's L1 balance and I see Alice's L2 balance. That L2 balance is from some tests before that were still hanging around. And if I see here in the client, I can see that I call the endpoints for commitments, for balance, how it hits the client, and how I create Alice. I can fetch balances if it doesn't do it properly for me, and then I will get that back. And then it goes, as you can see here, to the optimist, who also returns me logs. Now I'm going to do the same thing for Dave. So I'm going to switch to Dave. And now I see Alice is not green anymore, because we have that link. And of course, if there would be a productionized setup, we would have a one-to-one mapping and we wouldn't have both in the same UI. But just for the sake of this workshop, we are doing this. So what we're now doing is we're creating Bob. And we can see that Bob is active on the right side. Again, here on the client, we can see that we have a balance request. And it's really nice to see in the logs how we can follow these transactions. Now, having both of Alice and Bob here as our L2 users, what we have to do is we can deposit some wrapped HBar that we can actually private transfer with onto the contract. So we are going to do this right now. So I switch back to Alice just because Carl was the first one that I first used. And then I'm going to deposit some wrapped HBar in the contract. This is 60 wrapped HBar. This is not some other crazy number. This has 8 zeros because of the decimals that we need. Very important to know. And then I want to talk about that set fee 10. This fee is set by the proposer. The proposer will need that fee. So we always have to think you need to add the fee or you're going to put like 59.99999 or something. Now I can click deposit, and it wants me to sign the transaction because of course we're depositing this into a smart contract. And now I sign, and I can see here on the client already how the transaction hash is coming in. I see the proof, I see nullifiers, compressed secrets, and I can see the call and a 200 status of the deposit endpoint. It's going to take a while here, but I can see how this has also reached here the optimist. So the transaction handler has received something, and now we can do the same for Dave. This has not reached the proposer yet. This currently is just been going client to optimist. So if you think I forgot to show the proposal logs, oh, don't worry, we're not that far yet. Same situation here. We're going to put 50 wrapped H-bar. I'm going to add a couple of zeros, and I'm going to add the 10, the fee for the proposer. I'm going to sign this transaction also for my second user, which is Dave. And then again, I see here in the client how it hits there first, it generates the proof, and then it's getting picked up by the optimist. And now we wait, and ta-da. Now I already see people thinking probably, okay, what is now happening with the blocks? We could of course make a couple of more transactions to be sure that we create a block. However, we have here this nice cheaty button on the top, which says a nice and green make block. So we can click that one, and we're actually forced to produce a new block, which we've been doing just now. So you now see again here we have a commitment here, and then we now see how this is moving. Block proposed is showing up here in the events. This is new, we haven't seen that before. We see the received block numbers, we see the hashes, and then here we see again calling the endpoint for commitments. We go down, and then here in the optimist, we can see it received the block proposed event. So we now have a new block. Oops, being mindful of time, I will have to speed this a bit up. So having the new block now, I can see that my L2 balance has changed. So Alice as well as Bob have new money. Now I can move to the transfer, and for the transfer value I again can select, where are we? Can select something like 10k, let's say 20 wrapped H-bar, and I can see where I'm currently at. I am Dave, and then Dave is sending this to Alice, and I'm set off-chain. Why did I click off-chain here? Really important. Again, everything that's happening on L2 with these two users is fully private. It is not hitting L1. That's the reason why it is fully private. So all these transfers are instant like this. And also when I click transfer, you can again see how it's hitting the client and then the optimist. But as you have seen, it did not ask me to sign in my Rappi wallet. It did ask me to sign when I deposited, but not now in the contract. And if I go to my proposer, I see an off-chain transaction call here. I can do this now as many times as I want, and this solution is going to be fully private. Next, let's talk, because I only have a minute left, let's speed up and go to the withdrawals. So if I want to withdraw something, it will of course ask me again to sign, because all the withdrawals are going to touch L1. So Ruby Wallet will come up, Ruby Wallet will ask me to sign, and again here we can see in the logs, if we follow, how it hits the client, how it hits the optimist, and then the proposer. Now, really important here, the 7 days. We are going to withdraw, and we can see the 2 balance chains, of course, straight away, but the funds are locked in a contract, and they will only be able to be released after 7 days, after the challenge period is complete. So we don't have in this demo challengers, and we also don't have liquidity providers, just for the sake of time and complexity, but they are in the code. So if you want to download the repository, you can try this out as well, and also challenge some of these blocks. In this demo, everything was quite easy. Again, just to wrap up, we set Ruby Wallet up with 2 private keys, so 2 L1 users. Every one of these L1 users was used to create a person on L2. We deposited wrapped HBAR, which we got by sending HBAR to the wrapped HBAR contract, to the layer 2. We can do as many transfers as we want on that layer 2. It's going to be private, and the next time when we withdraw, we're going to go back to L1 and we're going to go back to public. I hope this was helpful. I hope that some of you will download the repositories, deploy the contracts, and try a couple of these transfers yourself. You can also, the contracts are verified also on Hascan. Unfortunately, we didn't have the time now to show you that. But if you go on Hascan, you can see the verified contracts. You can see the difference of how a private transaction looks like to a public transaction. If you have any questions, please find me at the studio station later. Talk to me, talk to Keith, or talk to Rohit, who's our second key expert. Thank you so much.
Yeah, just in conclusion, yeah, thank you to the Dean and Giuseppe for that great demo. Again, this is just to give you an idea. I mean, we're not saying you should use Nightfall, but you know, there's many smart contract solutions out there for privacy. This is just an example of one of them. If you're looking to implement privacy, and we hope in the future there'll be many more. The main call to action for you guys, we want to hear what your requirements are for privacy, whether it's enterprise or user. Please come find me and the Dean. We'd love to hear your requirements as a product guy, and we're looking towards the future of privacy on Hedera. So thank you all for attending.
Time to party. I think that's the last one. Let me see. Dude, I've been here. Oh, wait. Oh, there's one more guy. Okay.
All right, everybody. Hey, all my friends over in the builder zones. If you guys wouldn't
I'm going to shut up for a few seconds here.
Come up close for a little bit. Yeah, for Mark, all you guys. Come up close, all the people who are out there. We are at the conclusion of our Dev Day today in 2026. And I thought that we ought to first, if you wouldn't mind joining me in a round of applause for all the people who put their time and energy into putting this event together. All the wonderful, the food and the planning and the facilities and everything, thank you very much. Also for all of those who prepared and presented today, if we could give them a round of applause as well. After we're trying to make that come together. And thank you for coming and joining us today. Now, if you came to Dev Day and you leave without learning the name of one new person, I am deeply disappointed in you. Hi, Richard. Oh, hi. So, at at least meet 3 people, because following this, we have the happy hour. We're going to have socialization opportunity. At least you should meet 3 new people. And if you're on my team, you need to meet at least 10 new people. All right, 10 new people. Just mix it up. Let's get to know each other. Make some new connections. That's the real value of doing these things, is that we have an opportunity to get to know each other in a way that we've never known each other before, or maybe never have known each other at all before. So make sure that you take advantage of this opportunity to do that. I want to thank you for coming, spending the day with us, hopefully learning a little bit about what we're doing and some of the different ways to use the network. And that's it. We'll be back again next year, and I'd like to go ahead and invite Ed up. He's going to do the part that everybody's really here to listen for, which is like all these awesome things that are sitting up here that I really wish I was, able to win. But Ed, I'll swap it.
Thank you, Richard.
I think they're gonna.
All right, everyone.
I think they're doing a
Did
giveaway.
you enjoy Dev Day today?
Woo!
All right. So this is the moment that everybody has been waiting for. Now we're going to announce the winners.
$5
But before
each
we
bar.
get to the winners, I do want to remind you to register to HederaCon today. That's going to be in Miami on May 4th. And it's going to be another incredible opportunity with amazing content, amazing panels and talks. So be sure to join, that event in Miami. All right, so for the scavenger hunt winners, one requirement is that you have to be here to claim your prize. So if you're not here, we'll just go to the next person who ranked. What are the prizes? As I said, $3,000 worth of prizes. We got Quests or MetaQuest, Mac Mini, PS5, DJI drones, AirPods, Nintendo Switch, and a few more things there. So for our first place winner, this person's gonna come to the stage. You're gonna select your prize, whatever you prefer there, and then we're gonna take a picture, and then you can go to the networking session. All right, so Garrison, is Garrison here? Woo! First place with 975 points. This man was committed. What are you gonna get? All right, so your prize. Mac Mini, all right. Good stuff. Take a picture. Congratulations, Garrison. Second place for the day, we got Boulder Magic with 960 points, so that was pretty close. Boulder Magic, there he is. You're just gonna have to see some credentials here. All right, so pick your prize. He was going for the Mac Mini, and now he's going for the PS5. Great choice, great choice. Oh yeah, that's right, a picture. I think he was very excited to go unpack it and start playing right away. Awesome, congratulations. Third place, we got Crypto Goat. Man, these usernames. Crypto Goat, 960 points. Come to the stage. All right, and he's going for the Nintendo Switch. Congratulations, man. Thank you. Thank you. All right, so now for number 4, we got Mark Kina. Mark Kina, you here? Mark, hey. Congrats, Mark. That's 915 points. And he's gonna go for AirPods. Congrats, man. All right, we're down to our last 2. 5th place, we got Nicholas GV. Nick, all right. Nico, all right. Congratulations for those of you who haven't met Nico. He's one of our ambassadors in Latin America, so congratulations, Nico. And And he's going for the meta quest. All right. In 6th place, we got Juanma. Juanma here. All right. Congrats, Juanma. Woo. And he's going for the one choice he got, which is the drone. Congrats, Juanma. All right, everyone, that's it for the day. I hope you had an amazing Dev Day. I know I did, and I appreciate all the work, all the networking, all the amazing experiences that went on today. So with this, let's close the event, and let's go network. Thank you.
All right, guys, let me adjust this real quick here. All right. Thanks for checking in, guys. This is all going to be in the live playback, by the way. I know I was kind of zoned out for the last hour or two of that, but it was really all about the presentation anyways, so you guys can watch that back if you'd like. Again, sorry about the super loud music. There's not much I can do about that. I got a lot to close down here to get everything put in my bags properly, so I'm going to get started on that. We'll see about going live tonight. We went live for a good 3.5 hours here, so I feel like we kind of got it. Tomorrow on the regular stream, I could probably give a good 30 to 45 minute update on everything. So we'll see. I might just go network and have some fun. But yeah, normal stream tomorrow, so normal time. I'll just have to end it like 15 minutes early so I can check out of the hotel. Thanks for everyone for hopping in. You guys made this a lot more fun. Just kind of chatting with you guys for the past hour and a half. My brain is totally fried out. But I think people want me to start collaborating with them, so I am going to shut this thing down, and I'll talk to you guys tomorrow. Take care, wherever you guys are. All right, see you tomorrow.